you simply put that into Google. That will bring you to my homepage. So all the material is there. Yeah? I mean, for the first 3 lectures, and for the 4th lecture, I will give you the material. And it's, well, I don't know how it is precisely announced, but the lecture now, the official title is Topics on Degree Semantics. And when I was on the Esley Summer School, Hamburg, this summer, so Pignon gave a course, Christopher Pignon, he gave a course on degrees, and he says he was totally confused about Kennedy and that stuff, about all that talk about intervals, the Schwarzschild. I myself have done some stuff on degrees on 84. And there is a talk of degree intervals, and he found that totally confusing. So he gave 4 lectures and about the notion of degrees and interval, and he couldn't understand it. Yeah, so he was really totally confused. And I think there's some confusion in the literature, perhaps in my own mind, as you will notice. So I thought that the first lecture will only be devoted to the concept of degree, and I tell you what it is, and what degrees are, what I believe it is, and what is more or less compatible with the literature and the account. So that will, it starts in a relatively trivial way, but I promise you gradually it will. At each lecture it will go up, and I will come to more difficult stuff. And then when I come to quantifiers in then clauses, so that's the most difficult stuff, I can tell you a lot of hacking, and you will see then it becomes very complicated, and I'm not sure that there is any good solution up to date, and that's a good thing, because if we don't have solution, or we have solutions, but they're all very complicated, so I don't like them, of course, because I think semantics should be simple in some way. But then, there's something to do for you. So that's the plot, so hopefully they will bring the handout. That what they, le handout? Handout? No handout? Bonjour, c'est pas toi. Non, alors c'est Dominique qui doit porter le handout, il n'a pas porté. Le projecteur, il n'y a non plus un projecteur, je peux au moment, je peux un peu dans le vide. Okay, so I start you, what? Okay, yeah. So, why do we need degrees? I mean, people take it for granted, but for instance, the simple sentences, if we say something like that, Allah is taller than Sveta. Well, I mean, in the simple-minded approach would be that, you simply you take the 2 ladies, and you look at them and you compare them, and you see, well, one is taller than the other. So you could think that taller is simply it's like a transitive verb. It's like a transitive verb, and it means. Well, it takes 2 arguments. One applies, let's say, the most simple-minded reason, let me say, so the simple-minded solution would be that. So, taller, that would be a relation between 2 individuals, and then it gives you a truth value. I should say that I hopefully every one of you has read Hyman Kratzer, and Hyman Kratzer, and above all, that's why I'm going to assume, but I will introduce that in the second lecture, all my semantic assumptions. So basically chapter 12, so it's the intentional version of Heimkratzer, but I will give you all the notions. Yeah, but the simples, a very simplistic meaning of taller, yeah, meaning would be something like that. Well, you take two individuals, you take a lambda x, yeah, and a lambda y, and you say simply, well, x is taller than y. Yeah, so it's the other way around. So that's the subject, and perhaps in if you have an intentional version and you speak about words, you say in the word W. Well, that would be the common sense solution, but people thought it won't work, yeah, for very simple reasons. There are a lot of more complicated examples, because if you say, for instance, this table is larger, yeah, is larger than this chair is high. Yeah, the table is larger than the chair is high. Yeah, and so you couldn't simply state that as a relation between the table and the chair. Yeah, because what you compare somehow is the breadth, yeah, with the height. Yeah, so therefore, and what you have to say something is something. Well, the height, yeah, the breadth of the table, yeah, exceeds the height of the chair. Yeah, it's something like that. And what is the breadth? Yeah, and what is the height? This is precisely a degree of something, a degree of some dimension. The other things, for instance, the more complicated things where you see it. Yeah, it can't be that simple that you simply compare objects. If you say, for instance, Martin is taller than what we would have thought, something like that. Yeah. So what we would when you embed something, so it's really you compare it something with the degree. The degree Martin's height has in all the worlds of our thinking, something like that. Yeah. So, and it's totally impossible to paraphrase that by talk about some object. So there are good reasons, yeah, to assume degrees, yeah, in the semantics, and there are many things. Yeah. I mean, for instance, also question if you ask how tall, yeah. How tall is Martin, for instance? Yeah, you are asking obviously for degrees and not for persons. Yeah, how tall? It's obvious. Yeah, that you. And if you say, well, Martin is taller than that. Yeah, so you indicate somehow a degree and you compare it. Yeah, it's not simply a person. So, oh, very good. Are these the handouts? Are they very good? Well, there are degrees, and we start with saying what they are, because this is really a complicated thing. So let's take them for granted. We need them. And to my mind, it's a very important parameter. We basically have three important parameters, at least in language. There's a sort individuals we quantify over. There is modality, so possible words or situations, yeah, we need for modal interpretation. The other thing is then time, but time also has a variant where times are simply degrees at time, and we have degrees. Yeah, so so to speak, the implicit parameter of language. Yeah, at least four. These are perhaps also the event. Yeah, but this is under dispute, so it's one of the basic parameters language quantifies about. So we must know what are degrees. Yeah? What are degrees? Are there handouts? Is also perhaps also one for me? And the projector is not yet coming. Okay. There is among the stuff, yeah, you should read, yeah, is the it's a very good classical paper by Creswell because you can have it as a download. It's called The Semantics of Degree, yeah, and this is a very good paper. That's the only one, the first one, who's really explicit, and he gives a definition. I will basically follow Creswell in my exposition. There is another very good classical paper by Ewan Klein. You can also have it. It's a semantic of adjectives or whatever. I never remember the titles quite correctly. And he gives a construction that actually follows a man called Krantz. Yeah? And this is also very good, but Ewan Klein has a totally different semantics. Yeah? He starts from he has a pragmatic version of the adjective, so he deduces everything from the positive. I won't do that here. So the degree construction is very good, and the semantics for the adjective, people who like pragmatics a lot should read that. It's a very good paper. Yeah? Then Kennedy, there's a dissertation, and also another paper in 2001. It's about anomalies, and there's my own paper. There are two, and there are two of the years 84. Everyone quotes my paper about comparing semantic theories of comparison, but there is a second one in the same volume. It's called My Reaction to Creswell and some other people, and this contains the entire interval semantics. So what Kennedy was attributed to Kennedy mostly, it's already there, everything. Yeah, but in Kennedy's dissertation, this is also said. Yeah, that's pretty clear. So you should read that perhaps too. This is the stuff you should look into. Okay, entrée, l'ordinateur. Okay, so we start and we say what are degrees? Yeah, and to begin with, the main idea is a degree, yeah, like tallness, etc. It's a degree of tallness is an equivalence class of people or things, yeah, that are not that are indistinguishable with respect to tallness. That's the idea. Yeah, that's the idea. It's an equivalent class, so it's a class of concrete objects. Yeah, it's nothing abstract, so to speak. Our classes are abstract in some sense, but it's really a class of people. And now let us construct this. You think you will eventually what is Formulierungsfehler. You think I perhaps perhaps I have to make it sleep, yeah, and so wait a moment, and then we'll find it. Zustand. Wait a moment, and then usually, I mean, if I wake it up. No, it doesn't. It doesn't wake up. Jesus. I mean, now I'm afraid. Wait a moment. Oh yeah. No, it woke up again. Is it coming?
I think it's coming.
It's coming. Okay. Right. So, but this is too big. So we have to make. But this is here. I see it. So I can make it. Maybe. Oh no. I don't know. What is it? Not 100. Okay, now and somehow. Yeah, but to scroll it. Does it? Oh, yeah. Okay. This modern technique. Thank you. Well, we start now, and the idea is simply this, and it's also very important to notice, that the degree in itself, it's a very innocent notion, and you have to separate it, that's the first point, from the notion of distance. And therefore, like Creswell, I start with a thing like an adjective like pretty, pretty or beautiful, something like that. Yeah? And the idea is this: intuitively in the language, so we don't have degrees for beauties. Maybe if you are at the beauty contest, so these people, the judges, perhaps they have that, but ordinary people don't have that. But what we have intuitively, if we compare people, we say, well, that lady is prettier than that one. So I think I have an example. So Liz is more pretty or prettier than Marilyn. Yeah. So we can compare people with respect to prettiness, and intuitively we can say, well, that lady is prettier than that one, without knowing why this is so. Yeah? We simply do that. And if we have that, you see, we simply compare people, we have intuitively a scale. Yeah? So let's say intuitively we can arrange people according to prettiness. So this is here, this is Marilyn, and this is Liz. And then, if we do that for all the people, we, so to speak, certain people occupy. It's not clear what the distance between them, but there are certain peoples like Allah or whatever, and they occupy the same place on the scale, and all these people are identified, so we cannot distinguish them with respect of prettiness, so we put them together and take simply the class of all of them and say that's a degree of prettiness. And we can say, well, it's in a way the degree of prettiness determined by Marilyn. By Marilyn, so it's one exponent of this class here, one exponent of this class, well, and this is an equivalence class. And here's the construction by Creswell. There might be other construction. So intuitively, we are given a relation like pretty that's here, prettier than, I've called that a greater than with respect to beau, beauty. And, well, and you compare, you can define an equivalence relation, they, two people have the same degree of beauty, if, now that's the definition, for every z that are in the same, that are in the field of the relation, of this intuitive relation. Well, you say, well, either for every other people, they are prettier. They're both prettier, they are both prettier, or with respect to every other people, they are less prettier. And this obviously, you see, I mean, it's pretty clear if you look at this picture here, and you have certain ideas, and you say, well, these two belong to the same class, and you take any other people, you say, well, either, and they are not in the same. They are not in the same class. Well, either the two, are less prettier, or if another people is here, the two are prettier. And this obviously an equivalence relation. So it simply means if we have that intuitive relation, though the two are not, can't be distinguished with respect of prettiness. So this is really all. And now here's the construction. You see what a degree is. Once and for all, a degree of prettiness is simply the set of the people that are in the same equivalence class, the people that are not distinguishable with respect to prettiness. Is that clear? So that's a degree of prettiness. So for instance, it's if you have here an equivalence class, like it's the degree of prettiness generated by Marilyn, and this is the degree of Marilyn's beauty. And if you say that Marilyn is beautiful to that degree, you simply say something very trivial, namely, Marilyn is as pretty as she is. Yeah, so it's entirely innocent. Yeah, people. There are certain people who have argued that degrees are abstract things. We don't want them in semantics, but I insist here with Creswell, it's entirely innocent. Yeah, to have that construction. Yeah, I mean here the idea is now, I mean, each adjective of each degree adjective is based, so to speak, based intuitively on a comparative relation. I have called it here a comparative relation, or sometimes it's also degree relation. It's simply a relation between individuals that's anti-symmetric and transitive. Yeah, that's what you need, yeah, in order to. And then, of course, if you construct the semantics and people have a type of degrees, they call it D, and we collect all the different types of or degree types, because it's obvious. I mean, if you speak of pretty people, of stupid people, or intelligent people, or of heavy people, yeah, of tall people, so all the dimensions, so all the intuitive relations, yeah, that are, so to speak, basic, are totally different. Yeah, so if we really, there's nothing like a common notion of degree, etc. Intuitively, we must always know what is, so to speak, the intuitive comparative relation the thing is based on. Yeah, so don't forget that. Later on, when we go to semantics, people, and I myself, are very sloppy, and they forget that. Yeah, and but it's sometimes very important always to have in mind, yeah, what the relevant relation of comparison is. Yeah, okay. Now, once you see, we have degrees, and degrees are equivalence classes, yeah, containing people, and now we want to have a relation of bigger than, yeah, between degrees. Yeah, and you see, we started with an intuitive relation between individual, so we have to lift that relation to the classes now. Yeah, and well, that's in an obvious way. So we extend that relation, and we say, well, you see, if you have 2 degrees, say here, of prettiness, yeah, then we say 1 degree is higher, yeah, on the prettiness scale than the other degrees. Yeah, if for each person, yeah, in the first degree, yeah, and for each person in the second degree, so the first person is prettier, yeah, in the lower sense, yeah, it's prettier than the other one. Then the 2 degrees are arranged, yeah, on that scale. Still, at the moment, yeah, that's nothing like a distance between degrees, etc. Nothing. Yeah, simply, you see, think of the degree scales. It could be like a rubber. You could stretch it a bit. The relation between the degrees, yeah, the relative relation would still be the same, but there is no distance. Yeah, there could be a distance, but I assume there isn't one. So it doesn't follow from the semantics that there should be a distance. Yeah. Okay, and now we come to the first analysis, and to something like Liz is prettier than Marilyn. And the idea is, I mean, the first idea is, and when we want to analyze is the degree to which Liz is pretty is higher on the degree scale, the relevant degrees here, than the degree to which Marilyn is pretty. Yeah? And I mean, the first straightforward way of formalizing is that we say, well, an adjective like pretty or beautiful simply assigns to an individual its degree on the scale. Yeah, this is called. That's basically the way Kennedy does it, and he calls that a measure function. I don't do it. Creswell doesn't do it too, but for the moment, I'm assuming here Kennedy's approach. Yeah? And you could write it here in this way. You see the meaning here of beautiful and pretty. You say, well, it's it's a function. It takes an individual. It gives as the value the equivalence class with respect to beauty in which that individual is. Yeah? And you can write that. People call that a measure function. It's a sort of misnomer, but because at the moment we don't have a measure or whatever. Yeah? It's simply that here. And we can write that. That's very often used in the literature with big letters, beauty, and we say with the lambda x, beauty of x. Yeah? So it's a sort of Kennedy semantics here. And then we would arrive we come now to the semantics of the comparatives. And the simplest possible meanings of the comparative is that, the comparative also must be parameterized, relativized to the particular scale we are talking on and we are talking about. And in this case here, if we are comparing pretty object, we must have in mind the comparative relation of being more beautiful than. Yeah? And the simplest semantics that's possible, it's simply here now, it's a transitive relation that holds between 2 degrees. Yeah? This is, so to speak, the first one is the object, then comes the subject, and we say, the subject is bigger than the object. Yeah? So this is the degree relation, and we could formalize. Yeah? We could formalize Marilyn is prettier or more pretty than Marilyn, simply as that. You see that here. Pretty maps an individual to a degree. This also maps an individual to a degree. So we have here 2 degrees in the syntax. We apply the semantics of the ER, the comparative morpheme, and say, the beauty of Liz exceeds the beauty of Marilyn. This is straightforward semantics, the most simplest account that's thinkable. And you really might wonder, as you go on, why things become so horribly complicated later on. Yeah? And okay, yeah. So this is, by the way, we have a first problem here that is to be noticed. What about the positive? If we say Marilyn is pretty, how should that be represented? It's not at all obvious. Here if we say pretty assigns to Marilyn its degree of prettiness, so we still don't know what the positive should be. The positive means that she has, in a way, Marilyn has a high degree of prettiness. So that doesn't come out here, and we have to say something more about the positive. That will be done in second lecture, of course. And it's noted here. It doesn't follow automatically how this works. Now we come to a more complicated thing. Was everything clear so far? I think it's. Here the so clever people. So perhaps it's all too simple for you. But so I didn't know what to expect here from the public. So I started really. Oops. The base. So hopefully it still works. Okay. The next thing is we want to be a bit more in the to go a bit more into the detail and say something like introduce measure phrases like 1 meter 60 tall and something like that, or taller than by 10 centimeters, etc. But I don't start. People usually, all in the literature, they start with spatial measures. I don't start here with spatial measures because they're so complicated. They have complicated things because we always have to compare different ways, length, depth, height, etc. So I start with something simpler in order to construct now measure phrases. Namely, I start here with weight, weight. And I start with a very simple sentence, the goose weighs more than the duck. Okay. And this, of course, we can, we already have a formalization. I mean, more, take it for a moment, that's not correct. That's not what I eventually say. But identify the meaning with more at the morning, with the comparative with that of ER. And ER, do that. And, well, and let's say in the same way, we have that what weighs would have basically, it's a verb, but it would have the same semantics as heavy as something. In English, you can't say for some reasons it's 5 kilo heavy. In German, you can. So that's no deep reason here why that shouldn't be so. But in English, you can say weighs 5 kilos, right? And therefore, I take that. It's the same as the adjective, and weighs assigns to the duck the weight of the duck. And well, basically, it says more. It means here the weight of the goose is higher on the weight scale than the weight of the duck. And now we want to reconstruct. We want to say what does it mean? The goose weighs 5 kilo, and we also want to say the goose weighs, the duck weighs 3 kilos, and therefore the goose weighs 3 kilo more than the duck, right? Okay, that we want to analyze now. Now, see, what we need now is to construct something like 5 kilo, and n kilos, and we do it that way. We, you see, we start here. I don't know whether this is represented in an orderly way. Let's set maybe a bit later. We need a sort of an empirical relation of addition of things. So we start with ordinary things. So take the computer and chalk or whatever, and we compare these. There is a relation of catenating these two things. Namely, we take that one and maybe the other computer. We put it together on the scales. That's the relation basically. And empirically, we find out if we do that. If I take two of these computers and put it on one side of the scale, I take another computer, put it on the other side. Empirically, I find out this is heavier than that one. We know that. I mean, that's a really empirical thing, so it doesn't follow from the logic. It could be different. It could be lighter by some. If the natural source laws were different, but we have here an operation which I have written as plus here. It's for different objects, and it has that interesting property. Well, if I take an object A and maybe one of the same size, I put it on the scale, I get a new object. So take the fusion of the two things, and this is higher on the weight scales than the other one. So empirically, there is such an operation for simple things. And this operation, of course, we can define degrees of weight. Degrees of weight. So again, we have it. A weight degree is a set of objects. It's a set of objects that have the same weight, that give you, if you put it on the scale, give you exactly the same indication of the scale. Then they are, of course, in the same weight scale as you would expect. It's clear. So the weight, again, it's simple.
Have the same weight. The objects all have the same weight. What is showing that?
No, I mean, here, what ensure that maybe it was a bit short. The construction, the construction is exactly as it was before. Yeah, you have an equivalence relation. An equivalence relation that means weighs more. Yeah, you simply, of course, you have to know what it means to weigh more. You need a bit of, you must have already a scale. Is it in English? I think it's the scales. It's plural. I never know. What's the French word for the scale? Échelle. Échelle. You have to put it on. You have to put it on to think on the échelle. Yeah, then you know intuitively. Is English the scale or the scales? I think. Yeah, I don't know. The scales. You put it on the scales, and you simply discover one is heavier than the other one. Yeah. Then exactly as before, you construct an equivalence relation. Well, you proceed exactly like here. Yeah? You order the objects, yeah, and then you find out that certain objects occupy the same point at the scale, and this is the degree. This would make him 1 degree of the scale. Yeah, it's the same weight. Yeah, but so it's exactly as before. It's constructed that way, yeah. And here I was a bit. Maybe the exposition was not so clear at the moment because I talked about some stuff that's coming in the next section only. It's the construction is exactly as before, but the intuitive thing is simply the comparison is you put things on the scale, yeah, and then you construct degrees of weight, and you have here you have the degrees of weight. You can say what it means has a bigger degree of weight, yeah, and of course you can then simply it's obvious that you can now analyze, yeah, the goose weighs more or less than the duck, and for less, of course, you give at the moment. Again, that's not correct. It's more complicated, but for the moment it is correct. And less simply reverses the order, and it says here, the goose weighs more than the duck. It simply means that the weight of the goose is higher. Yeah, the weight of the goose is higher than the weight of the duck. Yeah? So this is nothing new. It's only the idea that you have to construct here this comparison class. But now we want to construct measures of weight in order to say something like goose. Right. Yeah. Now, what does it mean? The goose weighs. The goose weighs. What is it here? 5 kilos. Yeah? We have to say what is 5 kilos. Yeah? And I say here, it's simply a degree. It's simply a degree 2. Yeah? And you do it as before. Forget that as before you extend the elementary relation, the concatenation of weights to degrees, and you do exactly the same thing as before. You say 2 degrees of weights are bigger. Yeah, if everything that's in the first degree weighs less than anything that's in the second degree. Yeah, so this is obvious. It's exactly the same construction. And now, what is 2 kilos? Yeah? This is a construction done by Krantz in this, that's, so to speak, the Bible of measurement. It's Krantz 71. Well, what we must have, we start with a kilo in Paris. There's some... I don't know where it is, but somewhere in Paris there lies the kilo. Yeah? This is one concrete object. Yeah, it's I don't know what it is made. It's made some metal, platinum presumably or whatever. Yeah, and it's this gives you a unit of weight. Yeah, and you have that concatenation. I mean, if you have that kilo, you can form. And you have the scales, you can form other things, that other objects that have exactly the same weight. Yeah? These things you can, of course, concatenate in that thing. You put it all together on the way, and you can construct multiple of kilos. Yeah? So, and more abstractly, assume that you can concatenate that kilo in that sense that you that you construct another object that weighs exactly that much as that particular kilo. You can construct multiples of kilos, yeah? And you say, well, what is 1 kilo? 1 kilo, it's the degree. These are all the objects that weigh exactly as much as that particular kilo in Paris. It's clear, yeah? And if you concatenate, and if you have 2 kilos, so say we have produced another one, we have 2 kilos, we take all the objects that weigh exactly as much as these particular 2 kilos, and so on for n kilos. And of course, once we have done that, we can proceed also to fraction ratios of kilos, etc., because it's not important that we start with this particular kilo. Yeah, we could take exactly half of it, yeah, and take exactly half of it, start with that, and so on, and we go to the notion of the gram and the milligram and whatever. Yeah, so it's basically exactly the same construction. It should be. I insist here because you should have intuitively a clear intuition how these things are made. So it's nothing mysterious of that. So a unit of measure, if you have it, you must have by convention. Yeah, that makes it so complicated, and you must have a procedure, so to speak, an empirical relation of concatenation that tells you what is the multiple of this unit. And of course, if you start with beauty or intelligence or so whatever, it's difficult because you could have, as Creswell said, a unit for beauty, say the Calonne, yeah? But it's hard to say what this is. Yeah? So that's easy to agree what this kilo is in Paris, yeah, and what it is to have an object that has the same weight of that. Yeah, therefore, it's easy to construct that. Yeah, but for the Calonne and for the intelligence, that's much under dispute. Yeah, even though if you construct the IQ, perhaps there are construction, but it's highly doubtful. Yeah, that gives you a good standard. You could have one. Yeah, but it's not so easy, but for weight and spatial measures, we will see, and we have it. Okay, so we have, and look at the structure now, and what the multiples of a kilo is. They have that structure here. You see, we have 1 kilo, 2 kilos, n kilos. The important thing is, on the left. Won't happen anymore. The important thing is for n kilos, yeah, to look what it is semantically. So the n is a number, really, yeah, and the kilo, it's an equivalence class. Yeah, it's an equivalence class and containing one concrete object. Yeah, and the multiplication here with n kilos, yeah, gives you. You concatenate these things with themselves and gives you that degree. So ontologically, that's the measure phrase n kilos. So a unit of measurement, well, it's clear here. And how could we now analyze? Yeah, the goose weighs 5 kilos. Yeah, the goose weighs 5 kilos. Yeah, something like that. At the moment, the syntax we have done forces us to say that 5 kilos, yeah, intuitively it should be an equivalence class, yeah, but here in the syntax, if you take the expression, it should be a predicate of a degree predicate, yeah, of a predicate of degrees, yeah, And it tells you, it takes you a degree and tells you that this degree is equal to the equivalence class of 5 kilos. Yeah? So, and the goose weighs 5 kilos. What that mean? The weight of the goose is a particular equivalence class, namely precisely the class where all the objects are that weighs exactly as much as the goose. And this is equivalent, this is the same, yeah, as the equivalence class that's constructed by the kilo, and namely by the concatenations of 5 kilos. Yeah? So that would be the analysis. The analysis, it sounds all very easy perhaps, but it's, you see there's a lot of behind it. Yeah, you must have a clear idea how to do it. And it's clear when it comes to velocity and whatever, it's much more complicated, yeah, to construct the classes. Now, the next step will be we construct what I've called in my old paper differentials or differences, namely, if we say something like the goose weighs 5 kilo more than the duck. Yeah? So the analysis is this here. Yeah? You see, the first thing, yeah, the first thing to reason about what should be this difference, 5 kilo more. I mean, if 2 kilo more, yeah, you see, if I say the goose weighs 2 kilo more than the duck, I think the difference, yeah, the difference between 5 kilos and 3 kilos are 2 kilos. It's not a number like 2 or whatever. Yeah, it's really a number of kilos. Yeah, if you have, if you compare people and say, that lady is 10 centimeters taller than that lady, the difference, it's not a number simply, but it's centimeters. Yeah, it must be a degree, such a class. Yeah, that's really important. Yeah, you will find that in the literature there's a lot, you wouldn't believe it, yeah, a lot of obscurity. Yeah, if you come to differences, suddenly people say it's distances, something else, etc., but it's exactly the same. Yeah, and so the analysis would be here the weight, the goose weight. The weight of the goose is higher, bigger than the weight of the duck, and the difference in weight of the two is 2 kilos. Yeah, that's what we want to have. Yeah? And what we must have here, it's now the addition and difference of degrees. Yeah, obviously we need that. Yeah, and so the addition of 2 degrees, yeah, in the relevant scale is clear what you do. Yeah, you take 1 degree and the second degree, and you get a new degrees, and this new degree consists of all the objects. Yeah, you take one object in the first degree, another object in arbitrary in the second degree, and say, well, if you take the relevant operation of concatenation here, it's addition. Yeah, it's the addition. Then this thing here must be the result of this concatenation. Do that for all, yeah, and you obviously get the addition of the 2 degrees. Yeah, and the difference is, well, the difference is you do basically what is the difference. Yeah, I mean the difference if you add smaller number from the bigger one. Yeah, that's how it is difference. You must take that number that gives you when added to the smaller number gives you the bigger one. Yeah, and you do that precisely with the degrees here. I put it here in that way where you do it in the right order. So either it's that particular degree, and I have here well, it's not defined if you do it in the wrong way. Yeah, if you try to subtract the bigger one from the smaller one, but then you do it the other way around. So it's defined here in that way. So the difference, that's the important thing, is always a positive degree. Yeah. Okay, so that's the difference, and then we can also say what the differential degree is. So the biphrase, yeah, it's also my old paper, yeah, was basically done in that way, more complicated. Yeah, so you say the duck weighs 2 kilo less than the goose. Yeah, you say, well, the weight of the duck is the weight of the goose is bigger than the weight of the duck, and the difference is 2 kilos. Yeah, and right. Yeah. Now, if you look at the meaning of these adjectives here, the way I have done it here is by 2 kilos. Yeah, I haven't analyzed the by extra. What does it mean? It takes a relation, a comparative relation between 2 degrees, either more or less. Yeah, either more or less, and then it converts that into a new relation of the same sort, and it tells you it holds of 2 degrees, yeah, if the original relation holds, and you have the difference, yeah, and you have the difference. So it's a higher order thing that converts you either more or less into this differential relation. Yeah? So that's a way of doing it. Yeah? Other people have done it originally. They have said, well, the comparative relation have actually one argument more for the differentials, yeah? And you plug it in there. That's another way of doing it. Yeah? But I've done it here.
Does the relation takes an argument that marks it as less or more?
Yeah, it has to take that, and I mean there might be other relations between degrees, yeah, then it would produce nonsense, yeah. But I haven't. I'm only aware of these two. So this is, so to speak, if you would be more carefully, yeah, you would have to say that this relation R must be either less or more, yeah. Right? Yeah, you would have to say that. Yeah. Okay. Now we come gradually to the notion of the degree interval, yeah? And we say what a degree scale is. A degree scale, and you see, if we have a comparative relation, yeah, that was the intuitive thing, yeah, we started from, yeah. It's not what is expressed by the adjective. That's behind. That's the intuition, yeah, like prettier or heavier or whatever, yeah. And then we have a scale, yeah. We have an A scale, yeah, and this is simply a sequence, a sequence of these degrees, of A degrees, yeah, and ordered by well, that's not quite correct here. It should be in 2 brackets, yeah, by this higher order relation, yeah, by this higher order relation. So it's not quite correct. It's here, I guess it's the relation between individuals, but should be the relation by these degrees. Yeah. So you take degrees, yeah, and order them, and you get a so-called degree scale. Here's a remark that's really puzzling, but you will see that it's a source of a lot of puzzles. So what degrees, yeah, when we speak about degrees, they serve degree units, yeah, they serve 2 purposes. Yeah, something like the meter, you will see that in a moment why it is important. They localize an object relatively to an abject object, and they're comparative concept, but they also measure, in a way, you will see, the distance of an object from the beginning of the scale. That will be important. Yeah? I mean, at the moment, these remarks might be a bit obscure, so it's not so important yet. But now we come to spatial degrees. That's what most of the literature is about, and you will see why it's so confusing. And I mean, spatial degrees, usually spatial adjectives, they typically come in pairs of antonyms. Yeah? An antonym so we have things like tall and short, yeah, wide and narrow, long and short, I guess, yeah, it's and high and low. Long and short is double. Yeah, it's an error, yeah, but doesn't make it wrong. So, and the the conventional units, yeah, here in Europe, not in the States, it's the meter and the centimeter. I guess in the States I can't calculate that. It's foot and inches and that stuff. So I never know. So I talk, even if it's English, I talk about meters and centimeters because I know what it is. So and the problem, yeah, the interesting fact is somehow, yeah. So you see, what makes it so complicated, yeah, it's that we start with a sort of measuring, yeah, like the meter. Let's do it, yeah. So first we have something like positive spatial adjectives like tall and height, and obviously we can say, well, the height, yeah, if we the height of an object x, yeah, is well, there are those objects that can't be distinguished with respect to tallness or height. Yeah, that's clear. That's and wide. It's well, are those objects the width? Yeah, I mean, the degree of width contains those objects that are equal in width. Yeah, and length are those objects that are equal in length. But we'll see the problems like in a moment. The unit of measurement, it's the meter in Paris. Yeah, it well. 1 meter generates the objects that have the same length as 1 meter. And, well, but now, tall, yeah? I mean, you see, if one thing is 1 meter tall, maybe this table is more or less 1 meter, but assume it's 1 meter tall, yeah? I don't know it. And, but certainly, it's not 1 meter wide, yeah. So the broad, it's more than 1 meter broad. So we have to somehow to distinguish the breadth or the width, yeah, of the table from the height of the table. How could we do it? That's you see, it's still. It said it's 1 meter. Yeah, it's 1 meter, but the meter in itself couldn't make this distinction. Yeah, so it's obviously it's somehow. What is important here, and this is a source of confusion, is how we measure things. Yeah. So I mean, if we say it's 1 meter tall, we start from the bottom and we measure it in that way. Yeah, and we concatenate the meter sticks. Yeah, in that direction. Yeah. If we have the width, yeah, somehow we start from here and we go that way. Depth, it's very confusing. Yeah, you can say, well, the lake is 200. The lake is 100 meters deep. So obviously, somehow we start from the surface and try to measure. Yeah, try to measure the depth. Yeah, we go down in the direction of gravitation. Yeah, the other way height is, so to speak, anti the gravitation. I'm always confused if I look at the sofa. If I say, well, it's a sofa, is it broader than it is deep, or is it broader than it is long, etc. So or if you have a drawer, yeah, if you have a drawer, you say, well, the drawer is wider than it is deep. Yeah, is depth? Is it that, or is it if you go from the front to back, etc. So there's a lot. There's a lot of possible confusion here. There's a lot of possible confusion, and perhaps it's not even clear, yeah, when we use these adjectives what the standard is. But the intuitive idea is clear. Yeah, we measure along a certain dimension, and the adjective somehow should, if it were clear, it should express, yeah, the direction of the measurement of the concatenation. Yeah, so let's assume that in a moment, and we analyze Allah is 10 centimeters taller than Sveta. Well, we do it, of course, exactly in the same way, in the same way as we have done it before for the by 10 centimeters the modifier, and maps this ER into this taller by 10 centimeter gives you the difference. So that should be now. But now comes the complication. You see, if we have, these are the classical examples where we compare we go along different dimensions. And we have here, the table is longer than the drawer is wide. So I guess here the table is longer as that, and then the drawer is wide. Well, it's a large, or what the drawer is large. So, but we have a problem here. You see, if you carefully look at this relation, at this relation of comparison, this relation is always based on a certain way of measuring, of the certain. So, for instance, the length of the table is measured along that. It's along that direction. So we have the concatenation of the meter stick along that direction. And if we have the drawer is wide, perhaps we are lucky here, and it's not a good example. Let's say the drawer is deep. The drawer is deep would be a better example. Then it's certainly the concatenation is into another direction. It goes from the front to the drawer to and the table is deep. I don't even know what this is, but it would be that direction. That direction here, and so what could be the comparison? What could be the comparison somehow? I mean, that makes spatial degrees so complicated. This comparison somehow abstracts from the direction of the concatenation. So we have a certain length in mind, but it somehow we abstract from the fact that we do the measuring in a particular direction. That we couldn't abstract from these so far. Well, and the only way I could do it, I could imagine. I mean, what we have here, something more abstract. We have what we have is a quantity of a degree, or perhaps the cardinality of a degree, the cardinality of a degree, and that would mean we abstract. We still have the unit, that would be the meter or the centimeter, but we completely abstract from the direction, from this intuitive relation, how the concatenation, into which direction it's done. Perhaps it's simply that conceptual operation. And my feeling is also, by the way, and if I have, it's rather abstract, but the table is longer than the drawer is deep, something like that. I still have to think a moment what that could mean. So I think conceptually we have a problem here, because we, so to speak, we don't know. We also have a small problem of incommensurability here, but it's a problem it could overcome, because we know it's concatenation of the meter, or fractions of the meter. We still know that, and we compare that, so we abstract from that. That's the way I would do it. And okay, now we come to the next topic that will play a role, is negative adjective and degrees. So we have something like the negative pole of an antonym pair. It's something like short. So what should be shortness? First of all, I mean, it's the nominalization, the much more difficult. I mean, shortness presumably not not a good English word. In German, you could say in der Kürze liegt die Würze. Is there nominalization for shortness in French? Le court, hein? Le petitesse. La petitesse, court, la courtesse. Well, it's la longueur. It's a fact. Yeah, it's a fact really that when we nominalize, it's very easy for the positive antonyms. Yeah, you immediately find the nominalization. But if you go to the negative, there are a lot of cases. You don't, and this has, of course, a deep reason. You don't know, how to say that. And the problem is also, it's. I write here shortness. Yeah? I write here shortness, and the semantics still has it. Yeah. This is still defined. Yeah, because you have the shortness scale. We come to the moment what the shortness scale be, but it's a bit. The shortness scale, intuitively, it's already something very awkward, yeah. Because if you compare things, say with respect to increasing shortness, yeah. This is a funny scale, yeah. Think of it. You have increasing shortness here, yeah. So we start here somewhere on that scale. We have here 1 meter, yeah. 1 meter, yeah, and it's certainly so that 50 centimeters, it's higher on the scale because it's shorter, yeah. So we have here 50 centimeter, yeah, 50 centimeter, 0.1 meter, and if we have the maximum of that scale would be what? 0 centimeter, yeah, 0 centimeter, 0 centimeter, exactly, yeah, and now. What would be the minimum? Yeah, because you see here, I mean, if it's shorter, here we have 10 meters. Yeah? 10 meters has less shortness, yeah, than 1 meter. And if we go to 1 kilometer, yeah, 1 kilometer still less, and so on. So this obviously extends, yeah, to an infinity here, so it can't have. So here we have very big distance, so light years and so on, and so this is it's obviously a scale, yeah, that makes it perverse. And if you order it, yeah, if you order it by increasing shortness, it's very important. There couldn't be a minimum of that scale. It has a maximum, but it doesn't have a minimum. Clear? Yeah, that explains a lot of deviations. Yeah, no matter you implement it later on, and so let's have. So that's the scale here. Still, that says no minimum, and that you see explains in a way why you can't say 1 meter 60 short. Yeah, because there couldn't be. Or 2 meters short, yeah. In order to have 2 meters short, yeah, you should have a unit of shortness, yeah. But what should be 1 unit of shortness, yeah? And the 1 unit of shortness, yeah, where you start with something, what should that be, yeah? What I mean, so obviously you can't construct it even if you want that. So that's basically, I think. I have a problem, but it's basically the yeast, yeah, that must be behind every explanation of why you couldn't combine it with the measure phrase, yeah. And I mean, still, there is. I mean, I've noticed my old paper from '84, and has repeated a lot of times. The differences between shortness are perfectly clear in some, somehow, yeah. So we have. If I say Sveta is 10 centimeters shorter than Allah, or it's shorter than Allah by 10 centimeters, it's perfectly okay. Yeah, I mean, this we come to another. This is also intuitively clear, yeah, because you see here it's a shortness scale. If you have two particular things on that scale here, yeah, still the distance in some sense here, it's intuitively very clear. Yeah? So we have 1 meter, and here we have 100 meters, so the distance should be a degree 99 meters, I suppose. Yeah? This is pretty clear. This exists. Yeah? Though you couldn't have a measure phrase, a measure phrase that tells you 2 meters short. Yeah? You wouldn't know what it is, or someone does know what it is. I don't. I mean, so, well, and I mean, this here is, this I have, if you look at that by 10 centimeters, you see the way it is done, the way I have defined the differences that comes out, yeah, is defined, yeah, and so this sentence is defined as before. Okay. And so I come to anomalies. I've already anticipated how this works. Yeah, so you see, sweater 1 meter short, and I repeat what I've said, since there is no unit of shortness, you couldn't have it. Yeah. Now, the thing, unfortunately, I mentioned here a crucial fact that's now, it's a lot of debate about that. There are papers by Daniel Bühring, Irene Heim, etc. Yeah, and there is a so-called pattern of anomalies. Yeah, when that's in 84. Yeah, for instance, if you have Allah is taller, then Sweater is tall. This well, I anticipate already the syntax. It's already in the next. It's only done the next hour, but forget that the moment. So Allah is taller than Sweater, but you couldn't say Allah is taller than Sweater is short. Yeah, this comes out in the approach we have already. Yeah, because we have we compare things we can't compare, and we can also have Sweater is shorter than Allah is short. You don't say it that way, but conceptually it's clear you could have it. But you could say, people have said that Bierwisch and Bühring in his SALT paper gives a lot of examples that Allah is shorter than Sweater is tall. Yeah? And this here, the D doesn't come out from the semantics we have so far, because this is predicted to be anomalous. So I tell you why. And so here, what we have here, if we want to try in the last thing, so the last sentence, the D, should be something like this. So the first is bad. Yeah. So so the height of Allah exceeds the shortness of Sweater. Yeah. Well, that would explain, I mean, the anomaly of this here. So we couldn't formalize it that way. Neither could we formalize it that way in the tall scale, because it's obvious we couldn't compare. I will go into that another time. You see, shortness can only be arranged on the shortness scale, and height can only be arranged on the heightness scale. So we couldn't compare these. Yeah, so that would come out, but for the same reason. Yeah, this 48D that's judged to be acceptable is ruled out. Yeah? So the semantics I've stated here that way should say it's a bad sentence, and that's what Kennedy and I have said once. In fact, we've said it's bad, but people say it's good. Yeah? So we have a problem here. Yeah? I mean, okay. And well, and these are also other examples of the anomalies. I don't know how much time we still have. 4 minutes. And I go into the intervals, and I won't finish everything. And the interval semantics, if you look in my old paper in 1984, and Kennedy's dissertation, and also the paper on anomalies, yeah, they give a more complicated semantics for the adjectives. Namely, they say it's an interval. Yeah, it's an interval, and so the semantics is something like this of tall. It gives you an interval, yeah, comprising all the degrees that start of tallness, starts from the 0 degree of height to till the height of the object. Yeah? So, for instance, height, if we have the degree scale, a scale of height, it extends up to infinity, and we have here the height of Allah. Here's Allah on the scale, and then the adjective. The adjective would assign to Allah. Yeah, and so tall applied to Allah. Yeah, would be the entire thing. Yeah, that degree. So all the degrees that extend from the 0 degree up to the height of Allah, and the shortness. Yeah, the shortness would be the complement. Yeah? The shortness of Allah would be that. Yeah? That, and you could write it. You could write it that way here. And the most perspicuous way of writing this is the notation more or less in 51 I have been using, and also Kennedy. And this notation Irene Heim has used in more recent papers. And she says, well, tall, it's really a relation between an individual and a degree. And it tells you it holds of an individual and all the degrees, yeah, that are smaller or equals than the height of than the height of that particular x. And this is exactly what I've written here on the table. And if you the blackboard, yeah, and if you do it that way, yeah, you have a very elegant semantics of the comparative. Namely, you can say it's a subset relation between sets of degrees. Yeah? For instance, you can then say that Sveta is shorter than Allah. Yeah? And you can say, well, the shortness degrees, yeah, the shortness degrees of Allah are a proper subset, yeah, of the shortness degrees of Sveta. Yeah, as in these things here, because you see, in a way, yeah, this incorporates negations. So the shortness degrees of Sveta are all the highness degrees Sveta doesn't have. Yeah? So it's a negation here. Yeah? She doesn't have, and these are all the shortness degrees Allah doesn't have. Yeah? And the highness, the height degrees, and of course, you see, Allah is rich. Sveta is richer in shortness degrees than Allah. Yeah? So in other words, she is poorer, yeah, in height degrees than Allah. This, of course, incorporates in a nice way the intuition that somehow, that's what I thought in that old paper, in the antonyms, negation is somehow plays a role. It's included in the semantics. So, well, time is over. I stop at this point. We still am not yet finished the first part. Maybe, is it too slow for you? Is it too slow? But then we go on. Because I think, yeah, these conceptual issues at the initial are extremely important. Yeah? You really have to know what you're talking about. And then we gradually develop now more complicated stuff. Yeah? Okay. So, thank you. There was one question about the verb tiede, tiede to make lukewarm, something like that. Yeah? And this is the question was when the thing before the action, the thing could be very hot, yeah, and the action is to make it lukewarm. And before the action, it could be cold, and you make it lukewarm. Yeah? And I mean, this is not a problem at all. Yeah? I mean, I haven't. It's basically it's something like this. So I didn't go. It's something dynamic. I haven't entered tense yet, but I give you an idea. I mean, if you make it more precise, it's something like this. Yeah. So TD is you must have, we do that today, the idea that something is positively lukewarm. Yeah, positively lukewarm, so it must be slightly above. So it shouldn't be cold. It should be a bit warm. So it's above a certain barrier, and basically tiede. 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 Tie. Tiede. Tiede. Bon, c'est-à-dire, c'est faire tiède. Basiquement, c'est faire tiède. And what one has to do is basically to introduce. Then, if you go into tense, we have to introduce also a time argument. So predicates, of course, also depends on time. Yeah, and basically, basically the thing is this. Yeah, you have something. You have an abstract cause operator, and you have a subject. Yeah. And so Jean tiede le fer, something like this. So at the beginning, the iron might be very hot, yeah, or it might be very cool, and Jean tiede le fer. And the structure is here. This structure is, let's say, le fer tiede. So this is basically the structure, and this is a positive adjective. Here we come to the positive, and this is here a sort of a temporal property, and what you have to do, you have to do to define, the cause in a way, So the cause, what does the cause? We don't go into that, but basically it's simple. So what is the cause? It takes a temporal property, so it's something, a proper intention. Here we have a time and a truth value, and then you have a subject, and you say, well, at that time here, you get another property of time, and at time t, x acts or does something and acts in W at time t, or causes, let's say causes, causes in W at time t. Well, a certain proposition, namely another proposition, so a lambda W. So, and now at the end of the action, the fair is tiede. So basically, what you have here, and so this property, this is embedded, and this is the fair is tiede, and here you have the end of t, something like that. So it might be more complete, but it's not a problem at all. It's not a problem at all, because what you must have in addition, le fair est tiede. You have to know, and le fair tiede is at a certain. Le fair tiede. This is at a certain time. And if you do something, so at the end of the action, at the end of the action, le faire tiède, so it really doesn't matter. It's not said what it was at the beginning. Yeah, so at the beginning it can be very hot. Yeah, and at the beginning it could be very cold. That's all. Yeah, so you have to go on the positive. So this is a very this is a very easy answer. Of course, you have to go into a more what you have to do. What I won't do. To go into decomposition and to derive causative verb. Yeah? And basically, causative verb, tiéder, it's something interesting because the entry of the verb tiéder is basically an adjective, tiède, and then this selects an abstract operator in the syntax and cause. Yeah? And this, of course, you have to formulate, but I wouldn't do that. Yeah? But basically, it's very important, but by tiéder, normally you think you start from the lower direction. The thing is at the beginning it's cool. Yeah, that's. But there's another thing at Krivka, for instance. If I'm too fat, yeah, and I make I go to I make a cure or whatever diet, yeah, and then normally, and you say almost, yeah, you say I already weigh. I already weigh 90 kilos. Yeah? I mean, you see, he already weighs 90 kilos. Yeah, normally you already weighs 90 kilos. Yeah, you have the idea. So the already gives you a state of change. You have reached. Normally, you start from below of the scale. Yeah, and you go fatter and fatter, or you say the child. The child weighs already 7 kilos. Yeah, the baby, then of course it's growing. Yeah, but if you are very fat, you have another scenario, and you have the idea you lose weight. Yeah, and you say, I already weigh 90 kilo. Yeah, so you could go the other way around, down the scale. That's perfectly possible. Yeah, I mean it's here's something pragmatic. So the context must make clear. Which way? I mean, we would have to go into the semantics of the already, yeah, which I don't do. You had another question. I think it was you about distances, wasn't it? Huh?
Yes.
Yeah, what was it?
It was simply about the two notions as degree and distance, because you said that the notion of degree is completely harmless and innocuous, but later you mentioned the notion of degree. Already explained that for you the distance is a special kind of
and the thing is this, to repeat it, you see, when we start with the construction of degree, like say most of the adjectives are comparable, so we have prettier, and we have I don't know, intelligent, or these things, then the only thing intuitively, what is given, you compare people with respect to intelligence without knowing what that is. So the intuitive relations, comparative relation, you know more intelligent. I mean, it's also difficult to have it, but say heavier, etc., and prettier. But let's say we can do that. We can judge people according to prettiness, and then what we do, we can compare people and localize them on a scale, so to speak. But we don't have a distance. We don't have a distance, and the distance needs obviously certain culture and standards for measurement. And the standard of measurement, as I had two examples. It was the kilo in Paris, and it was the meter in Paris. Again, what is the meter? The meter in Paris is a very concrete stick. You can. I think I don't know where it is in the Bourse. Oh, where's the meter here? I mean, it's somewhere. And where is it? Place Vendôme. Place Vendôme, you can actually, if you, I don't know if you can do it, presumably it's protected very much, but some people, you can watch it as and you can touch it. So it's a very concrete thing. And then and of course, and I mean, if you have, it's a very old idea. People have, of course, weighed and measured already in the antiquity. But what you have, we have a certain standard. You have a certain standard, and if you make other meters, concrete sticks, they should be exactly as long as that in Paris. We have another problem because the thing could expand, etc. So it should have a certain temperature, etc. So that would be the size. So, but it's a concrete thing. It's a very concrete thing. And then you have the idea of that's the unit. That's the unit of measurement. So the unit of measurement, it's one very concrete object. That's the idea. And the same with the kilo. It's made of a certain metal, etc. It's a concrete thing. And then we have the notion of concatenation. So we put, the idea is, we can take the same thing, put it here, put it there, and think of the abstract thing here of one concrete thing again. Or we have two sticks of exactly the same kind as that meter and put one after the other. That would give you length. And if you concatenate them that way, that would give you height, and if you concatenate it starting from here, it would give you depth in some sense, and if you go from the surface down, there's a handout, and there's a handout somewhere at the beginning. You measure depth, that's the idea. So in other words, you must agree on a certain standard of measurement and how you do it. It's quite clear how you do it with spatial degrees, and how you do it with weights. So that's obviously, I mean, when people negotiate, etc. So it's obviously for this society it's very important. But for the other notions, say cleverness, and beauty, etc. Well, I mean, you should develop a notion of. You could develop perhaps a standard, but it's not at all clear how to do it. First of all, I mean, what should be? You know it. For the IQ, for the IQ to have points, etc. There's a lot of debate that's mostly very culturally based. There are certain questions, and you solve certain mathematical puzzles, etc. But I mean, certain people. I mean, usually people say that if you take away all the cultural bias, the people that do best of all are the Inuit. So all the Eskimos, that seems to be the most clever people, given the standards of the IQ. But other people, for instance, if you go to Black Africa and you ask certain people, so they couldn't do it as well with certain grammatical questions, etc., because they don't have training. But all the musical abilities, etc., are not taken into account. So what would be the measure for an IQ? So obviously it's very difficult. And what would be the measure of beauty? I mean, we have different races, etc. So could be maybe when I was young, studied in Grenoble and had a very black man, and he said, "Le noir, c'est la couleur de la beauté." Well, that would be one parameter. For instance, it gives you a very high range of points. If you have a black skin, other people think maybe the white skin is prettier, etc. So what would be? I mean, that's for people. And as you know, if you go to a judgment, if you go to art and literature, etc., there's all that question of aesthetics. So what would be? So we simply have the very vague idea that we really language speaks. Well, that is prettier than that. And we say de gustibus non est disputandum, etc. But it's only that idea. But to give a standard, obviously needs conventions, and also an effective method, of how to use it somehow. So that's it. And there are very few. I mean, so it's not astonishing. It's not astonishing that we have certain people have thought that the notion of degree is really an essentially in an essential way connected with measurement. It's not true. Yeah, this is the only thing I wanted to say. Yeah, if we have measurement, so for special for weights, etc., and also other things, yeah, of physics. Yeah, we have velocity and maybe also charge and these things. Yeah, and so we have certain standards, but it's not astonishing that for most comparative adjectives we haven't. Yeah? I have said something about tiede, as I say it again, so it's very easy. Yeah, I mean, tiede basically means to make tiede, and tiede make to do, and you have to decompose the adjective in some sense, and so to make lukewarm, yeah, to make.
There's no degree there.
Well, that's a positive. There is the degree is we come to the positive. You see, something is positively warm, positively lukewarm. Yeah, so it means when even there's a certain degree. Yeah, because to be lukewarm, yeah, you have to be on the heat scale. At a certain position, there are things they're ice cold, yeah, and they're ice cold. Certain are cold, yeah, and then you can.
That's the point. It is used when you go to -2.
Well,
That's the point.
well, the negative. I mean, depends a bit how you conceive of the scale. I don't know. You see how natural language does it. Yeah, I mean that.
The idea has 2 scales.
Right. Yeah, but no. I think here's. You see, the point is simply, yeah. If you do it that way, I make the iron, I make the iron lukewarm. Je tiens de le faire. So, that's. You have temporal dependence at a certain time. Yeah. You do something. Yeah. You act so that the end of that time and the last moment. Le faire est tiède, yeah, and it's not said at the beginning of the action, yeah. The iron can be ice cold, or it can be very warm, yeah. It's not said at all, yeah. So the only thing that matters, yeah, it's that my action, yeah, produces the effect that at the end, yeah, of the action, the thing is tiède, yeah. So, and I give you another example. I repeat it for you. Normally, if I said I already weigh 90 kilos, yeah, no, or the child weighs already 10 kilos, yeah. So usually, you go up from down up, and you go to a certain point. But if I make a cure and I want a diet to make, and I want to lose weight, yeah, I can say I already weigh 80 kilos, yeah. If I started with 90, yeah. So this is really. It's really not said here in that change. Normally, it's a pragmatic thing. Yeah, you start from below. Yeah, you start from below, you go up. Yeah, but there are the scenarios. Yeah, with tiede peut-être where the initial thing it's not said, and the lexical semantics where the thing when you start, it's really very hot. Yeah, and voulait tiede, and at the end of that action, it's tiede.
Tidir and cool. Tidir is just a state where to cool you can have
Right,
more or
yeah.
less cool, something there. Something to do with that. But tidir can be
Well, right, yeah.
on the skin.
Yeah,
Whereas to be
yeah.
warm can be here on there. Or
Well, you make it also warm. I mean, I mean, it's not precisely the point because I'm not talking about time there, but since you brought it up, I give you an idea. So, I mean, it's a bit so what the scale is. Yeah. So the scale of temperature. Forget about physics. So below 0. So here we have ice cold, something like that. Yeah. So ice cold, and here we have I don't know. Here we have nothing. So normal. Or no, it's very cool. It's cold. Yeah. And here we have I don't know, but here we have lukewarm. That's tiède. Yeah. And here we have warm. Yeah. And here we have, I don't know, hot, etc. Yeah. And so basically, you reach this point here, and if you have cool, yeah, if you cool it, well, it's hard to tell. Yeah, presumably you have a conception, because we don't have a word, yeah, for ice cold, yeah. But for instance, I cool it if it's really, presumably you don't say it, but you could conceive of it. If people had that distinction, yeah, if the thing is really much below zero, and you find someone on the glacier, the first thing you do, you cool it, yeah, but you wouldn't say it, yeah, because if it's really cold, yeah, and to cool means to make it cold, yeah. So you have the idea it's really you're at the bottom of the scale, therefore presumably at the beginning of the action the thing has to be above cool, yeah, and then you bring it up, yeah, that at the end of the action it's cold, yeah. So that's what it means presumably. So it really takes. The thing is, yeah, you can have both direction if you are not at the bottom or the top and the scale. You have to be somewhere in the middle, and here there seems to be such a thing, yeah. But of course, mostly it suggests that you go up a bit up from downward. That's the normal interpretation, I guess. But you can also, maybe not. Yeah, okay. Yeah, well, that's my reaction. Okay, so let me say where we are to the literature. What I said. Yeah. Okay.
Whether there could be two fundamentally different kinds of readable things. On the one hand, we have standards based purely on convention, like meter, inch, pound, kilo. But on the other hand, there seem to be things and standards anchored somehow in nature. Let's take, for example, the measurement of time in physics. Yeah, so the precise standard for measurement of physics is the oscillation of seasons patterns. Or let's take, for example, the so-called golden cup in geometry. Or there might be something like perfect beauty, so 100% of beauty.
Yeah. Well, two questions. I mean, time. I avoided that, but let me tell you how I conceive of time. Yeah, I mean the two. Time also might figure as a degree. It's for instance, we have the adjective later or earlier. Yeah, so we can compare it. What is time? I think of the world. It's a flow of all the events, yeah, and so think of the world here as a big sausage. Yeah, it's think of the world as a very big sausage, something like that. Yeah? So and time. So that's the world. I mean, it's the picture is not so really complete because there's a flow of the event. And then there are certain individuals or the pieces of speck inside. These are the events or the individual, yeah? And many of these. So that's a sausage. And at time, one thing, it's simply a slice of the sausage, yeah? And to be located at a time, yeah, to be located at a particular time means you are part, yeah, of that part of the world. That's my notion. This is, so to speak, not yet a measure of the time, but this localizes thing. So in this respect, time is only a part of the world history. Yeah. So in that sense, but time obviously have a length. Yeah. This is duration. Yeah. And then it comes to what you have said. Yeah. You measure where there is a way of to measure. You must have a conventional mean, and there's Foucault's. No, there is the what is it? The pendulum. Is it called in English? It's a pendulum. So you must have a regular an event. Yeah. That and there is what was the cesium. Yeah. It's the oscillation of some blah, blah, blah. I don't know what it is. And people simply, they believe or they hope it's a regular repetition of the event. Perhaps that it's not, but that's what they take as a standard. And it's regular if you get, after all, if you do this measurement, you get a simple description of reality. I mean, that's Carnap, who has done a lot of that work, etc. You could take anything, for instance, the repetition, so every morning when someone brings you the newspaper, you could take that, and it's a measurement, but if these people, of course, don't always come at the same time, that would not be the best thing of doing it. And I mean, so that's also a convention. I mean, the convention was basically when we started. I mean, you know it, our language. So it's the sun, or the moon. So it's the raising of the sun, and we measured the day by the movement of the sun. That was not a very good method because we know that it's not always the day. A day is basically the distance from the sun going up and the sun going down, and this, as we know, is not exactly regular because it's shorter in the winter and longer in the summer. And therefore they went to other convention, but it's again a purely conventional thing. That we somehow what the repetitions are. So we must have it's also a convention. So, and I mean, the other thing, so this is in a way, if we have a dynamic thing, dynamic thing, obviously we must go to nature, or we have the pendulum, and this is gravitation, if it moves that way, and we hope it's always, in fact, that's what people believe, it's not disturbed, it's quite regular, so it's also a convention, But it's, and the other thing, you are right, I mean, there's less arbitrarity. If for instance, for the measurement, that's what I said, it's, for spatial measure, there is still this other thing, how we do it, and how we conceive of the distances. So, and we don't have that when we measure, when we measure the time. But of course, we have relativity. But I'm not going to speak about that. But that's the answer. It's also a convention. But the method we do it is different. Okay, there was. Okay.
I have a question about what you said at the end of yesterday's lecture, and perhaps you want to come back to it today. But after you showed us the contrast between John is shorter than Mary is tall, which is good, and John is taller than Mary is short, which is ungrammatical. You introduced a new meaning of degrees as denoting. A new meaning of adjectives as denoting sets of degrees. But with these sets of degrees, it seems to me that we still can't explain this contrast, or did I miss something?
You want, what do you want to say? We can explain the contrast with a set of degrees. No, what was the question exactly?
The question is whether, with the semantics that you introduced at the end of last lecture, whether we should be able to account for this contrast.
We come now, we come back to that. There's someone who told me about that. By the way, there was also after the talk. Was it you who said me that there's a good interpretation? And you said it. I come to that in a moment. Let's take up otherwise to go a bit here, and because I was very short here. Let's go back where we. Where is it here? Okay. Right. And the first thing, I want to say when we are now coming back to that in a moment, so speaking of shortness, think that was a bit quick at the end, If there are two ways, of they basically come to the same at the more abstract level of conceptualizing something like shortness, I mean, the idea is, if we say Sveta is tall, Sveta is shorter than Allah, let's forget about this pattern in a moment and first speak about shortness. The idea is we want to have shorter. She has a more of shortness. So obviously that's because it's shorter. It means more short in some sense. Yeah, we want to conceptualize it that way. The first thing is we have rescued. That was perhaps not so clear to a different degree scale. Yeah? A degree scale, namely, so that's the conceptualization Creswell does. Yeah? Creswell does, and perhaps, and so the tallness scale, yeah? Increasing tallness, yeah? Tall is that. Yeah? And so I'm a bit here, so increasing tallness, say here, it's 1 meter. I'm a bit sloppy. There are all classes, but forget about that. Here we have 2 meters. Something in between, of course. Yeah, and so on. Here we have 100. Yeah, and up to infinity. So this is obviously, if we arrange people along this scale, there's no maximum on that scale. That's clear. Yeah. So we have a minimum. Yeah, and someone is 0 meter or I mean, if we take the equivalence class of 0 meter, obviously they don't contain anything, because everything, physical thing has a length. There might be things that have no length, but let's assume at the moment the ordinary thing has nothing, but there's 0 meter, the equivalence class. Now, the shortness scales, if we arrange things, it's clear that 1 meter is shorter than 2 meter. Yeah? So on the shortness scale, it's clear that the things in 1 meter have more of shortness than the things of 2 meters. Yeah? So let's arrange it that way. So we do it a bit the other way around. We have here 1 meter. Yeah? And so 2 meters have less of shortness. Yeah? And 100 meters still have less of shortness. Yeah? Still have less of shortness. And of course, if we go here, it can go on. If I go to 0 meters, that's the end of the scale. So that's the maximum of shortness. So it goes that way. Now, shortness the other way around. But here, obviously, I can go on. I have here 1 kilometer, and so on. So obviously, this scale here of increasing shortness can't have a minimum. It has a maximum, but it has no minimum. If we arrange it that way. So, and we would have here 2 scales. I can denote this one as the scale here, let's call it tall. And here we have a second scale that's called short. That's called short. And it consists of the same thing. It consists of the same thing, but they're simply arranged in an inversed order. That's the shortness scale. Now, there is another thing, and if for instance, I mean, to explain here, that's the first explanation. If we do it that way, we can explain. You look now at the patterns of so-called anomalies. If we look at that, I mean, that's Creswell's explanation. And this is good because Allah is taller than Sveta is tall. We go to the tall scale and we say, well, Allah is here, Sveta is here. Sveta is here, so Allah is taller than Sveta. No problem. We are on the same scale. And we don't have a problem with Sveta is shorter than Allah is short. Because what we have here, of course, is Sveta is on the shortness scale higher than Allah because Allah is here. No problem. We are on the same scale. And but if we look to that now here, Allah is taller than Sveta is short. What can we say? You see, the problem is there are 2 different scales involved. And the comparison, comparison presupposes one particular scale, but obviously there are 2. So what could we say? We couldn't. They're incommensurable. So that's the idea. And the same. you see, people have said Allah is shorter than Sveta is tall. Yeah? Given the present theory, people have said this is good. Yeah? And there's no explanation for the goodness, yeah, of this sentence given in the present theory, because there's still two different scales involved. Yeah? See, that's the point I wanted to make. That's one ontology. Yeah? And now I go to a different, that was a bit short, there we were less, and we come to the notion of interval semantics. And to make clear, the interval semantics makes now a slight conceptual switch, because we don't go to different scales, to different scales of when we speak about the negative adjective short, but we stay on the same scale, namely only the tallness scales, and define shortness different from height. Yeah, so that's a conceptual difference. So, for instance, in my paper, in this my reaction, I hope, by the way, I fixed the home page. So all the downloads should work. Yeah, I've done it more or less. Britton and Kennedy does it the same way. If you look at an adjective, basically it does this. Yeah, it gives you, for a particular object, all the degrees, yeah, up to the height of the object. Yeah, so in this interval semantics, you start here if, for instance, if we have Allah, we only have the tallness scale now. Tall. It starts from here, goes up to infinity, and the adjective, the tallness of Allah, of this measure function, here is Allah. Yeah? Here is Allah. That's the height of the Allah. Gives you all of these integrates, of these intervals. So this is this here. That would be the adjective applied to Allah, conceived as a meta function. The shortness gives you, in some sense, the complement. Yeah. But here, the way I have done it, and Kennedy did it, including also the common point. Yeah, including the common point. Later on, Irina Heim has done it with pure negation, so with the exclusion of the point that says advantages and disadvantages. So the shortness of Allah, is then this here. This is the shortness. You see, it's exactly the complement. And again, and if you look at that, you see, if you look at the tallness of Allah, so the height, this has both a minimum and a maximum. This has a minimum and a maximum, this interval. This here has a minimum, namely the height of Allah. It doesn't have a maximum, because it's, as I said it, it's basically all the degrees, that Allah doesn't have, including the degree she has, including the degree and plus all the degrees she doesn't have. So that again gives you that interval. If you do it that way, you can have a very elegant semantics. Namely, you simply say something in terms of subsets. You see, if you see that picture here, if you have Sveta is shorter than Allah. So basically you say Sveta is shorter than Allah, so Sveta has more of shortness than Allah, because Sveta has all these degrees here, and Allah has all these degrees here. So it's clear that the shortness of Allah is a proper subset of the shortness of Sveta. So that's a switch to interval semantics. It's conceptually a bit complicated, because here you think in a way, and Kennedy also occasionally makes a confusion. He says that this thing here this interval is a degree, but that's not quite correct, yeah, because this is a set of degrees, and either, well, if in each case, presumably an infinite set of degrees, yeah, if the scale is dense, yeah, but in any case, if you take shortness, yeah, it's a set of degrees that doesn't have a maximum, yeah. In that respect, yeah, I want to insist it's really not very different from the other way, whether we have two scales and arrange it in a different way, yeah, because what you have here also, you see, you also have incommensurable thing. Kennedy and me too, yeah, that's my terminology. I've called this here initial segments, yeah, of the scale. I have called positive degrees, and final segments I have called negative degrees, yeah. And I've said that negative adjectives, yeah, denote negative degrees, yeah, and positive adjectives denote positive degrees, yeah. And in terms of the subset relation, the proper subset relation, you can only compare either initial segments, positive degrees, or final segments, yeah. Otherwise, if you mix the two things, you get an incommensurability, and that explains anomaly, basically, yeah. So that was my old account. Kennedy has taken it over, yeah. And then, in order to say, you see, that's another thing. In order to say what measure phrases do, and you couldn't say 1 meter short, yeah, but you could say 1 meter tall. The idea is, yeah, that 1 meter in tallness reflects also the distance of an object from the 0 point of the scale, and it should only be combinable, you know, with a positive extent, yeah, and you see, and 1 meter tallness, and again, yeah, it's defined, or 1 meter 70 in tallness, yeah, because you could start with concatenations, yeah, with small things, but 1 meter shortness, yeah, can't be defined, yeah, because what should be a unit of shortness, yeah, because you have to start something and concatenate things so that they get shorter and shorter. At least, I mean, you might invent something, yeah, that does it, yeah, but what should that be, yeah? I mean, so this is the explanation. So by stipulation, you simply say, I've not done a much better way, that measure phrases are quantifiers here that are only defined for initial segments of a scale. Yeah, that's the way I've done, but it has the intuition. So it's a bit of technical. It's a bit a technical trick, yeah, to do it, but the intuition is very clear. Yeah, that 1 meter tallness is a good class, and 1 meter shortness can't even be defined. Yeah? Yeah.
No, in German you can say she's 1 meter small, or she's really young.
Speak louder. I can't hear.
It's sure, you know, in German you can say she's 1 meter small, or she's really young. It's not the German, and actually contains
yes.
judgment.
Yes. I mean, this 1 meter 70 klein, you could say that, yeah, but it's a marked thing, so it really means it means she's 1 meter tall, and this is small. Yeah, so you reinterpret it in that way. There's also yeah, that's related to what's your name? What was your name? Huh?
My name.
Yeah. Grégoire. Yes, that's what he said. Yeah. So you said that Allah is taller than Sveta is short, yeah, that this has an interpretation, yes, it has one. I mean, what would it be? Yeah, it's taller. So there we have another intuition. I come to the positive today. It's something, so what Grégoire said is something like this, yeah. Say, I mean, I will come to this today. We have here increasing tallness. here we have the neutral zone, yeah, of things that are neither tall nor short. Yeah? And if Allah is taller, then Sveta is short. Yeah? It means something if we interpret that way. Well, you see, here the tall thing starts. The tall thing starts, or say Martin. Allah is not that tall, but Martin is tall and Sveta is short. So here we are, say, at 175. Yeah? And here are the short things. So it's say 160. I don't know what it is. And Sveta, perhaps it's 158. Yeah, that's Sveta. Yeah, and Martin is here. That's Sveta, and this is Martin. Yeah, that's 2 meter. Yeah? And I mean, and the idea is, yeah, when we interpreted that, I think that's the interpretation I get, and you presumably too. So that the distance of Martin, yeah, from the point where the tall things start, yeah, from 1 meter and 75, that's actually 25 centimeters, yeah, it's bigger than the distance, yeah, from in the negative direction from Sveta, from the point where the small things start, yeah, where the small things start from upward down, namely only 2 centimeters. I think we interpret it that way. So it's what we learn from that. I mean, if we start from the conception, most of all people, if we interpret it that way, but if we hear a clear statement, we try to do something about that, and the conceptualization of course we have leaves open that interpretation. Yes, okay.
I was thinking why we can't say Mary is taller than Peter short is because the comparative metric clause actually compares 2 degrees, but a clause like Peter is short does not take a degree argument. And the reason why we can't say Mary is shorter than Peter is tall because the first degree in the metric clause is due to the comparative, not because of the Mary is short, and then Peter is tall.
From which country are you? I mean, what is your original country? China. Yes. There is just a different intuition. Yeah, that's in Russian. Yeah, someone we have a Russian. Yeah, we have a Russian speaker. You can't say that either. And you can't say. I think you can't. You can't say. You don't have these sorts of comparatives, and this means, yeah, if you have an open clause, yeah, if you say Sveta is taller than Allah is tall, yeah, then the embedded thing is automatically interpreted if you make it open. Yeah, if you really make the adjective open as a positive adjective and has a totally different interpretation, but that's not, according to the standard theory. I mean, we never. I have to add another thing. For I always said here, Allah is taller than Allah is tall, but actually that's not what you say in English. That's what you analyze. You say Allah is taller than Sveta is, or than Sveta. So I come to the syntax now. But if you make it open, it's in fact possible, yeah, to interpret it that way with a positive operator down. Yeah, that's quite right. Yeah, but the way it is interpreted, yeah, and then I come to the syntax today, and with some deletion, yeah, then it gets that other meaning. But it's quite possible that when you make certain things explicit, you certainly have that other reading you have, yeah, and you certainly you have that. And in some languages like Russian, for instance, yeah, it's automatically so. So, for instance, you couldn't say in Russian, Allah is 10 centimeters taller than Sveta. That's not possible, is it? Oh, that's possible, yeah. So what was not, no, you can't say, no, subcomparatives, you can't say the table is broader than the drawer is deep. That you can't say. Well, I mean, but it's quite right. Yeah. So have in English, maybe you can't make these things. You certainly can say in English, yeah. You certainly can say the rope is longer, the rope is longer than the table is broad, yeah. And there it's clear, if you have these subcomparatives, we come in a moment, that the embedded thing is not a positive, yeah. But you are quite right, it could be a positive, and in some languages it always is a positive, and that makes the construction totally anomalous. Yeah? The Chinese is a totally different construction from English. Yeah? I know little of it, but a bit. Yeah? Okay, now I have to make a bit of progress. Some notes to the literature here. A note to the literature. I follow Creswell. Another, there are few, and I've mentioned, of course, my own approach and also Kennedy. And there are other constructions. For instance, Krivka has done a lot of work about measure functions here in different articles. And what he has done, he has an approach, a measure function, something like meter, maps things directly into a measure function, always maps in individuals into a number, so meter somehow, something like 2 meters, maps an object into the number 2, yeah, and a degree is then something like that that are mapped by certain measures. It's a set of things. It's given here on that table, that are mapped to the same number by some measure function, and he also has then the notion of the cardinality of a degree, namely the cardinality. The cardinality of a degree is the number to which the things are mapped to, and then you can define also a relation between degrees and addition and so on, and multiplication. The thing is, the important thing is also for Krivka, degrees are classes of things. Yeah, that's important. Yeah, that's important. And I don't like this approach because, of course, in physics, etc., we conceive of we always work with numbers, but hopefully you always had the same problems as I had at school when we had an equation like S equals half of G times T square. Yeah, then you first of all you learn at school that you couldn't add apple and pears. And then, when you're in physics, you always divide. You always divide different things. So you divide meters by time, etc. You do it all the time, and so you really have to ask what it was. Yeah, but this is really it's this puzzle. I was always very puzzled. Yeah, by reading these equations, because ultimately, you see, you calculate with numbers in physics. Yeah, and the things, but you should never forget what these numbers stand for. Yeah? I mean, if you go back to the interpretation, for instance, if I have this equation here, yeah, this equation here. So this is here then the gravitation, and this is the square of the time, etc. So the dimension. So we have 2 dimensions. So at the end, that should give you meters. So this is T squared quadrat, so that G presumably should have the dimensions meter divided by second quadrat. So that's the dimension, and you really have to have to ask yourself what they stand for. But so if you only to quickly count into numbers, you don't know, you forget what things are in a way. Yeah. So okay. Huh?
I have a question
data we're discussing this contrast, so the alleged contrast between Marius is taller than Jack short, which is Jack is taller than Marius short. It's actually not clear to me. To me, both are okay with this special implication.
Yeah. Okay.
I actually don't feel it. Maybe a very slight contrast. What the assessment of the data.
Yeah, I mean, there's. I mean, I won't talk much about that. So there is a paper in, I think, in the Salt, of last year, yeah, and there, or maybe it's 2 years away. So Böhring gave a talk, yeah, and he brought it up, yeah, that it's a lot of hacking. Yeah, it's also, I mean, my homepage here, that paper. So what he says, yeah, I mean, without qualification, he doesn't discuss, yeah, that reinterpretation. So Allah is taller and Sveta is short is bad, yeah, but he gives a lot of, Allah is shorter than Sveta is tall, yeah. He gives a lot of examples from the Google that this is actually, even with pictures, so that this is acceptable, yeah. And I mean, so basically it's shorter than Sveta is tall. Basically, yeah, that should mean Sveta is shorter than Allah. Yeah, and so according to him, yeah, Sveta is shorter than Allah. So it should have really. That's what also Bierwisch claims. Yeah, so Bierwisch claims, if you look at the elliptic thing, that Sveta is shorter than Allah. That should be represented as Sveta is shorter than Allah is tall. Yeah? That's what that's the claim, more or less. Yeah, and here, of course, if you have that ontology, well, that's what I thought. You first would predict it's, in some sense, it must be anomalous and reinterpreted, right? Yeah. So they think, and I don't think that's quite correct. Yeah. They think it's entirely correct. Yeah, to say it, but I'm not so sure. Yeah. But he has a lot of data in that paper. Yeah? Okay, so basically, recall from the thing here with Krivka is you can go to numbers, but that loses information. It doesn't tell you anymore what these numbers intuitively stand for. Yeah, because later on when you do calculation in physics, etc., there's a certain point where you go back and say, well, it's that. Yeah, if you interpret it and you map it to reality, it's not simply a number. But maybe it's velocity or it's a distance or it's a path into one direction, etc. So what you always have in that what you must have in mind. Yeah. Okay. Well, Kennedy, I said so. I go to the that you can read, and I go here to the next to make a bit a new material. I go to the next thing. And I tell you something about syntax. Yeah, this is here. Let's have a look. I don't know why it's always so small. 100. Okay. Yeah.
The differences between your account
Yeah. Okay. Yeah. Okay. No, I didn't. I see. I mentioned my account. I didn't go seriously into it because it's so complicated. And Krivka, it's basically does something like, because I did the comparatives in form of addition. Yeah. And later on, basically I said Allah is taller than Sveta. I did something. I said something, well, there's a positive degree, D, and Allah is Sveta's tallness plus D tall. Yeah, that's my original account. And Krivka does something very similar. Yeah, you see this here, Krivka's comparative, yeah, is this here, and that's your question, yeah. And I mean, and let's have a look how this is done. This here, yeah. And the first argument is, so to speak, an empty spot. It's an empty spot for a differential. Yeah, it's an empty spot for a differential, and you can have here. Alla is 10 centimeters taller than Sveta. What the air does, the first thing is the adjective. The adjective is a relation between a degree and an individual, and it tells you the individual is tall to that degree. Yeah, so it's really like my approach. And then the second argument, it's a measure phrase. It's 10 centimeters, and the measure phrases here are only degrees. So it's sets of objects. Yeah, and then what it says here, there is a d. Yeah, and well, that's now. Sveta is d centimeters tall, and Alla in centimeters is d tall plus 10. Yeah, and this only gives you and these 10 centimeters enter in that place, and then Sveta is tall. That's the usual stuff. Yeah, that's the then clause. We come to that today. It's a set of degrees such that Sveta is tall to that degree. And if you have, now here we have, it's 10 centimeters taller, but if you have simply, Alla is taller than Sveta, yeah, and you don't have these 10 centimeters, you must insert an existential quantifier, and you simply say at that point, yeah, so there is a degree for these 10 there is a degree, a positive degree, yeah, and so Sveta is the tallness of Sveta. Sveta is there is a degree. Sveta is d prime tall, and Alla is d prime tall. Alla is d prime tall plus plus that other degree. Yeah, so that's basically the relation. So basically, it's also in my approach, and you make the comparative relation more complicated. Leave another spot for the differential degrees. Yeah, either insert an open differential degrees like 10 centimeters, and if it isn't an open, you must say there is a positive degree. You insert it, and somehow an existential quantifier in the syntax. So that's the way it is done. Yeah? Okay, yeah. So that's okay. Then that's, was this answered? Yeah? Okay. Yeah? Okay. Now, second, syntax. I think it's really important to have a good idea what the syntax is, and I give you now the standard view, and I give you perhaps in a few words my own views. It's not quite as it is in this paper. I believe more in an approach a la Williams. Yeah? And so the syntax of comparative clause hasn't, it's one of these good things, hasn't changed much since Bresnan. Yeah? I mean, I don't look, Bresnan's paper is very complicated, but basically the architecture is the same. It's already an old paper by Chomsky, who said that then clauses involve a WH movement. It's also incorporated here. And well, and the actual thing, yeah, I mean, I do in the way follows follows handouts by Irene Heim. Yeah? I have my own similar, but since my comparative is a bit complicated, yeah, I don't have included here, but the max operator that we'll figure out later on very much was my invention. And so standard syntax, so what does it? So I have this usual picture. This usual picture is Chomsky has in GB theory, or perhaps also minimalism is not so different. Yeah, I mean, so minimalism has a lot of branching points in a cycling way, but for the rest, it's mostly the same. Yeah? And the idea is, yeah, that we have S structure, or maybe spell out if it's more fashionable, and you convert these things at one part to a logical form, where everything is explicit, and the other thing it goes to phonetic forms. So the thing I conceive of it at the moment, so the standard way is this here, and details, I mean, you might arrange it slightly different. You see, we have John is taller than Mary. It has two versions. It has two versions. John is taller than Mary. This is called comparative deletion in a way, because John is taller than Mary. So all that stuff here, you see the deep structure is here. Then Mary is WH tall. So all this is WH tall is deleted. So this is a comparative deletion, and if only part of it is deleted, John is taller than Mary is, and we leave the is. So we have deleted only the AP. And this is called comparative deletion. Right, or subdeletion. No, it's excuse me. It's if you leave the is, this is subdeletion, because you leave something. The other thing is deletion or comparative deletion. Okay. Now you start with this deep structure here. Then you do the phonetic form. That's not what I ultimately believe. That's a better way of doing it. But the phonetic form, you do it. You delete something, and here either subdeletion or deletion. And now you construct the LF. The LF, it's basically this here. The important thing is, I'll give you a tree in a moment, that the then clause, the then clause, it's something like what Mary is tall, then what Mary is tall. It's a complement of the comparative morpheme. That's the way people do it. I say something I don't think that can be literally true, but that's the way it is done. And so the deep structure is this here. So I have a look at the classical deep structure. So we have here the comparative morpheme. You see, this is a strange thing, because when later on at the LF, and maybe in the syntax, the then clause, which the entire thing should be QR'd, but in the phonetic form, this thing here, then Mary is tall, must somehow be extraposed, and the ER is then affixed to the tall, and that's a very strange process. If you look in terms of incorporation, etc., so that's very odd to do it that way. But that's the way it's standardly done. And now, what is the construction of the S structure? At the S structure, or maybe the LF, it's not so clear whether that belongs to the S structure or the LF. We have, you see, the important thing, we have here the tall. The first argument of the tall is a degree phrase. Degree phrase will ultimately be a generalized quantifier over degrees, so it takes a set of degrees and maps it to a truth value. That's what it will be. And so this here, and we have to, inside of that degree phrase, we have a WH movement. You see here, we have a WH. What is a WH? A WH, or an operator with Chomsky, I assume here, Hyman Kratzer's theory of totally empty, semantically totally empty things. And if something, you see, the tall requires at that particular place here something of type D. And tall, the way I do it here, will have the type, takes first a D, then it takes an individual, and then it gives you a truth value. But here we have a nothing, semantically nothing, so we can't leave it there. We have to move it. And the movement will create a variable of type D. Then it goes to a peripheral relation, so the WH, And the movement index in the theory by Hyman Kratzers will be interpreted as a lambda operator. And after movement, the WH, which is nothing, will be deleted. So basically, this movement creates lambda abstraction. That's the idea. Yeah?
In deep structure and in circle structure, you have tau appearing twice. And then it disappears. And at the end, you only have one tau.
So
you have tau which appear twice. You have John is then Larry is WH tau, and tau. You have twice.
Right.
Tau.
Exactly.
And then one of them disappears.
Exactly.
Where?
Yeah. Well, I mean, let's have we go, here it disappears. Yeah, that's precisely. You see, let's go back. Yeah, and you see, the deep structure. What is basically done? You see the deep structure here. This here. Yeah, yeah, and the S structure is done. We WH move that empty thing to that place here. Yeah? We still have the two things. Yeah? Now, perhaps we extrapose the thing here to the end and insert the ER to the adjective. So this ER moves to that adjective. So we have that here. We extrapose the entire then clause. You can see it here that it's extraposed, but for instance, if you have another sentence, so Caroline observed more birds than Arnim did. Yeah, you see that the then clause is always extraposed in the syntax. And here, for some reason, that's precisely what Bresnan says. Yeah, we have deletion. Either we leave Mary is. Yeah, you see, Mary is still the remnant here, and this is still in the AP or the sentence here, and the rest, this here and this here, is deleted. Yeah, that would be subdeletion, yeah, plus extraposition, or you delete the entire adjective phrase or maybe the VP, and this is called comparative deletion. And what is left? What is left? Yeah, after this deletion, is the tall in the main clause. Yeah, the tall. And the tall in the then clause disappears. That's the standard syntax, right? Not my invention. Everyone does it. Yeah? Everyone. Yeah? Okay, there's a phrasal construction, and John is taller than Mary, where you don't do it all. But you see, if we have John is taller than Mary is, yeah. Is, and you do it that way, yeah, and you see it that you have a finite verb in the then clause, so the entire thing has got to be elliptic, yeah, that's not other, but it's clear, yeah, so that's the standard way of doing it, yeah, and the thing is, remember that, and that's why I insist I do a bit of syntax, that's the basic structure. It looks a bit unfamiliar, and you have to spend some time, yeah, and semantically, it's perfectly reasonable to do it that way, and also the syntax, yeah, it's really comes out also. Okay. Okay, now, you see, this is here, that's a deep structure. Yeah, we form the S structure by WH movement, yeah, and now comes to the phonetic form. It's clear we do a bit of deletion. And we have now the construction of the LF. Yeah? You see, basically, the main idea of constructing LF is things are where they belong to. So if you have, you must have a clear idea what the logical type of the phrase is. And if a quantifier stays in an argument position, that either requires something of the individual type, yeah, or here of the degree type, you have to move it, yeah. And this is this is a movement for avoiding type clash, yeah, avoiding type clash. So it's one essential idea for doing QR. And the other thing is, you simply delete stuff that doesn't have a meaning, yeah, like empty preposition and that stuff here, and the then that doesn't mean anything, etc. This I call. I credit to Chomsky Chomsky's principle of full interpretation. So at each interface, you only want stuff that can be interpreted at that interface. So at LF, you only want stuff that can be interpreted phonetically, and at LF, you only want stuff that can be interpreted semantically. So I delete the then, yeah. You see, this is then the transparent LF here, and I ultimately will also delete the syntactic categories. Yeah, it's a bit like Stabler, because we don't need them. So the syntactic categories that simply reflect the category of the verb, etc., it's not necessary. So the only thing that will be left will be the logical types. So 7 is basically what we have, and I will give you a tree with the logical types a bit more below. Yeah, I mean, so, but that's the transparent LF. You see, what you have here more, yeah, more than Mary is tall, John is tall. Yeah, so that's basically the tree you have. Now, I introduced the semantics. It's entirely standard, yeah, but I insist, of course, that everything has a clear meaning. I assume here that's not necessary, but an intentional logic, precisely as in Heim and Kratzer in chapter 12. The basic idea is, yeah, that the basic idea of an intentional language, and that's so confusing. If you have, you always insert, so to speak, an abstraction over words. Yeah, you have an invisible word argument. So if in the syntax, yeah, you have something of type T, it's really a proposition, yeah, that gives you a function from possible words to truth values. Yeah, so that's what it is, and you do it always. So you always insert invisibly a lambda W, yeah, and insert. So that makes it a bit confusing, and the point is, so I have the usual types. So E for individuals, T for truth values, and D for degrees, S for possible words. And then we have the intentional type here. If something is, if you have a given type A, you prefix it with an S. That's an intentional type. So the syntax is the usual stuff, and the usual stuff. So you have functional application. Yeah, you have a functor and an argument. Yeah, and an important thing here in Heim and Kratzer that's important is if you have there's a rule of of intentional functional application as well. If you have a modal, yeah, I'll give you an example, but that will also play a role. If you have a modal like must, yeah, in Kratzer's, has everyone read Kratzer and also chapter 12? But okay, but I repeat it here. So, for instance, if you have must rain, yeah, must rain, yeah. It must rain. It must rain. So basically, here you have something of type T. Yeah, I forget here. I leave away. I leave away the time. Yeah, and this here, you see, it's a modal operator. It requires something of type of the proposition type ST, and it combines, spits out then a T. Yeah. And here we have seemingly a type clash, yeah? A type clash because the argument is of type T, but what the functor requires is something of type of the propositional type, yeah? And this is resolved here. So this is allowed in the syntax of Heim and Kratzer, and you need a special rule of interpretation, namely what you do here. You take the meaning of the functor, and usually if you do a functional application, well, it comes in a moment, you won't apply it to the extension of the argument, to the truth value, but what you take is a proposition. I have done it in the wrong way because the semantics is introduced only later, because up to now we only were at syntax, so we have the lambda operator, that's clear. We have the semantic domains, individual truth values and degrees, and we also have possible words for the functional types, and we have the type of the functions. Yeah? And then we have now the interpretation. Yeah, here. Excuse myself. I should say it at that place here. You see, what is important here? Yeah, is if you have a lexeme, it's always an intension. Yeah? So for instance, if I have a verb like sleeps, yeah, sleeps has the type et, but if you look at the semantics, yeah, semantics is lambda w, yeah, and lambda x sleeps in w, yeah. You don't see it, yeah. So this word argument, you could make it if you would use an extensional language, as Sigrid Beck does, yeah. In the last lecture, I will look at the paper of Sigrid Beck. You could make it explicit. Here, it's left implicit. Yeah, that's Hyman Kreutzer 12. You can read it there. And the important point is, you see, if variables, you see, we have a lambda abstract, but that gives you only the value of the variable under an interpretation. And ordinary functional application, you see, we have two functional applications. Under 3, we have the extensional functional application. Here, it's only called FA. It means you want at the end an intension, a lambda w, and you take the intention expressed by the functor, apply it to the point w where you are, then you take the result, that's an extension, apply it. Now you take also this beta here. This beta is an intension, but if you apply it to a w at a local point, it's an extension. You apply it to that. And so the two w's are bound from outside. So entire things, it will be an intension again. But here, if you go, you see, to functional to intentional functional interpretation, it's a bit different. The functor is interpreted as before, but the argument, the beta, we don't apply the beta of to the w, so we could that write as well as so this beta as lambda w, then beta applied to w. That would be the same. Yeah, but you simply take the intention of the beta. So this resolves in a way the type clash that's admitted in the syntax, and it's resolved here by a special rule of semantic interpretation. Yeah, that's what you can do all the time. Yeah, so that's the usual stuff. And now the measure functions. Yeah, as before, the measure functions are function now of the type ed. Yeah, individuals, and the values of the function are then degrees, yeah, in the set, so equivalence classes. So, for instance, here we have the measure function height, yeah, as before. We know it already. We have lambda w, then we take an individual, lambda x, and we have x height in w. This is the set of those things, yeah, that have exactly the same height in w as x. Yeah, so it's a class. Yeah, and well, with the IQ, if we have something, so we take the set that have the same IQ in as that individual, and so on with the weight. And now I take, for the time being, yeah, one adjective semantics, namely the version of Heim. Yeah, in that's a paper about degrees in 2000. And I take the tall, you see, lambda w, which we have always, is not so important. The first argument is a degree, the second argument is an individual, and now we take an interval, yeah, we take the set of all these degrees, yeah, that are smaller or equal to the degree of Irene Heim, so the x. Yeah? And so this is precisely an initial segment of a degree scale. Yeah, that's initial segment of the degree scale. Yeah, and now the intelligent, same thing. Yeah, well, this is the thing I will work at the moment. And as I said, the comparative has a very simple semantics. It takes two sets of degrees. Yeah, so the lambda p, lambda q, and it simply says, you see, the p is, those are the degrees expressed by the then clause, yeah, and the q are the expressed by the main clause, yeah, and it means that the degrees expressed by the then clause are a proper subset of the degrees expressed by the main clause, yeah, right? Yeah, so this is now there are a couple of equivalent formulations, namely you could say, let's have a look whether this is equivalent. Yeah, exactly. So here we simply make, you see, here I have the big sign of proper subset interpretation, and this is here in 15, it's made explicit by universal quantification, so every degree of the first set is in the second, yeah, and there's a degree in the second set that's not in the first one, yeah, so that's the same, yeah. And you could also say the maximal, that's more similar to what I've done in my old paper, so you have it's a relation between two sets of degrees, and you say, well, the maximal degree that is in the second set, it's bigger, yeah, than the maximal degree that's in the second set. This is obvious, yeah, because if you have such a relation, you could also you get exactly the same thing if you go to the endpoints and compare these. Yeah, you don't have to speak of about every element in the set. So that's equivalent. Yeah. Okay. Now here, the usual stuff, and you have here the entire tree. Yeah, and the entire tree. This is what I call a transparent LF. Yeah, it must be something like that. You will see, of course, in the third lecture, it gets more complicated because the facts are so. But this is, of course, the way it should be. Yeah? Then the nice syntax. So everything must be arranged around something like that. You see, here we have the then clause, and everything is very transparent here. You see, here we have this trace here, and this trace, yeah, is generated by the WH movement, yeah, inside the then clause is then deleted, yeah, and this is the set of degrees that Mary is at least as tall as this degrees here, so it's an initial segment of the interval. Here we have the subset relation, yeah, it's so we get that interpretation here. This is called this trace here, yeah, is generated, yeah, by extracting this entire generalized quantifiers more than Mary is tall by QRing it to the initial position, or perhaps to the end of the sentence, yeah, to make it more to the surface. And then at the end, what you get, of course, is that the initial segment of the height scale that covers Mary's height, yeah, it's a proper segment, yeah, of the initial segment that goes up to John's height, right? So this gives you precisely the correct interpretation, right? Everything clear. So this is completely standard, and here, of course, I have here a picture that gives you the truth conditions. Yeah? Okay. Now the negative adjectives, you see. There are two ways. I mean, Irena Heim gives a systematic. Is it finished? Yeah. Oh, good grief. Yeah. So, okay, maybe. But we ask a lot of questions. So I think it's also important. So we continue here. So read a bit and make a bit of. Let me repeat where we what we have reached. I mean, the official LF is this one, so Mary is taller than John. It's we start. I mean, the complement clause. No, John is taller than Mary. The complement clause. Then Mary is tall. Is the then clause is a complement of the comparative morpheme ER. That applied, you see it from the logical type here, that applied to this then clause will give us a general quantifier. That means that the height of Mary, so all degree, so it's that initial segment, that initial segment of the degree scale, all the degrees that are smaller or equal than Mary's height, yeah. they are a proper subset of the main clause. This is QR. That's what we have. That's where we are at the moment. And now the official at the moment the official meaning of the comparative is this one. That simply it's a relation between two properties or predicates, and it's simply proper subset relation. It always comes to this, so that's it. Now, a bit more complicated, what is it here? So measure phrases, I've said they are either measure phrases are restricted to initial segments of the degree scale. And now we come to more gradually. I speed up a bit, because I would. So the program, it's still to come, is I want today come to handout 3 and to the problem of quantifiers and then clauses. And so initially we propose two theories. They are Schwarzschild and Heim, and they both have difficulties. And then the last section I will present, that will be tomorrow, a proposal by Sigrid Beck. It's still more complicated. So see, it will speed up a bit. I mean, when if you look, this is a famous example in Russell's 1905 on denoting. I thought your yacht, so A says, the yacht owner says, I thought your yacht was longer than it is, and the answer is no, my yacht, the touchy yacht owner says my yacht is not longer than it is, But this is of course not so to speak, not the meaning of the first sentence, because I mean the meaning A had in mind is the actual length of the yacht exceeds the length it has in the words of my thought. So for instance, I mean I might think that the yacht is between. The length of the yacht is between 14 and 18 meters, but actually the yacht is only 10 meters long, and then I can say I thought the yacht is longer than it is, But in, for instance, in when you say I thought. There is another meaning, at least, I mean, in German it's pretty obvious if you put it in the subjunctive. Ich dachte, Ihre Yacht wäre länger als sie sei. That's totally out. So this is contradictory. So the thought could also be, that, so what B attributes to the yacht owner is that's what he thinks, that my yacht is longer than it is, and this is of course not possible, because the yacht cannot be longer than it is. If you say it in plain sentence, my yacht is, or I'm taller than I am. It's the same thing. It's contradictory. And so to make it here consistent, you see here in that theory, we have it here. We simply QR. I mean. We start from the sentence, the deep structure is, I think, and that's the deep structure or the S structure if you want, and I think the yacht is more than the yacht is long, and then we have two, this here is a quantifier, and we have two landing sites for the quantifier. We can QR it either to the top. Forget a moment that this is long QR, perhaps it's not allowed, but that's what you have to do here. Or the other thing is, you can quantify it and remain under the thinking, because this is here, we have a clause here, you can QR it to that point here. That will give you the inconsistent reading here. So I start here with the consistent reading. You see, you start here with the more than the yacht is long. You take that and QR it, and we give it matrix scope, and then you get that here, and you see it's a consistent reading because it means, so take all the sets, take all the degrees that go up to the actual length, up to the actual length of the yacht, and this is a proper subset of the length of the yacht has in all the words of my thinking. By the way, this is a thing we will encounter later on as well. This will give you a minimum reading, because I mean, this is a universal quantifier, and if you go, if I think my yacht is between 18 and between 14 and 18 meters, so in some of the words of my thinking, it's 18 meters long, and some of the words of my thinking, it's 14 meters long, and some of this all compatible with of the things. So one of these, but of course the set of degrees, that satisfies the length the yacht has in all of my this is a handout. In all of my thinking words must be the minimum. Recall that semantics, it's made in a way that we have downward monotonicity. So, for instance, if the yacht is 18 meters long, it's also 14 meters long. This is in the semantics, so it's put in because recall that the adjective means x is d long, that the height of x, it's bigger or equal d. Therefore, it goes down to every degree. So if I have 10 euros in my pockets, I also have 8 euros in my pockets. So that's the idea. So so this was the consistent reading. Well, the inconsistent reading is generated, as I told you when you scope here the then clause or the are then clause, so the degree phrase under the think. And then what you get, I forgot that's the usual meaning of thinking. So thinking is what is called, it's a modal operator, and here it's what is called a verbal quantifier. So thinking means basically that the proposition, it's true in every word, and that is compatible with my actual thinking. So it means in every word where every think, every proposition that I believe of the actual word is true. That's what it means. So it's a general quantifier. I mean, it's a modal of necessity, but only with a subject here, special epistemic modal of necessity. And I mean, and here of course you get, you see, you get the inconsistent reading. You QR it below, and what you have here in all of my thinking, in all the words of my thinking, the yacht, the length of the word exceeds its own length. That's of course not possible. Right? So this is here straightforward, and straightforward. And I have now I say a bit more about the syntax. You see, we have to distinguish locality conditions for QR. Here in this case here, I have QR'd. I mean, I have QR'd out of over a verb of attitude. Some people don't like it, but I think it gets you the correct reading, so I do it. And but there are other things. You have to distinguish that from restrictions for WH movement. Recall that in the then clause, we have to move the WH that is originates. Then my yacht is tall. That's the yacht is WH tall. This is scoped, and of course, if there are restrictions, the well-known restrictions for WH movement. Here are examples from Kennedy, where, for instance, you can say Mercury is closer to the sun than I thought it was. That's Russell's sentence. Yeah, it's only that's the one we had. Yeah, and now we had. You see here, yeah, Mercury is closer to the sun than I wondered whether it was. Yeah, that's no good. Yeah, and why? Because we see that to give you in a moment the structure. We have here a WH island. Yeah, so the then clause is here. So when originally it's here we have a gapped adjective phrase, and the WH that's here originate in that position, so it has to cross that weather here, so it's no good. And Mercury is closer to the sun than I knew, who said it was. Yeah, here we have a WH phrase, so we have WH island, perhaps also affective island, yeah, because we scope it over new. And complex MP constraint, so Ross constraint, Hill-Bopp was brighter than Carl claimed it would be. Hill-Bopp seems to be a comet. And Hill-Bopp was brighter than Carl's claim that it would be. Yeah, Carl's claim, here we have extracted the WH out of complex MP, yeah, and here Hill-Bopp was brighter than the paper that it said it would be, and this is also a complex NP, yeah, because a paper we extract out of a relative clause, yeah, and we have of course an adjunct island. So the solar flares were more energetic than the Aurea Borealis was. That's fine, yeah. And the solar flares were more energetic, so the more is moved here, energetic than we were amazed when the Aurora Borealis was. So it originates at the WH somewhere here, and this is of course the when, yeah. It's an adjunct. Yeah, we can leave it away. Yeah, and we're amazed when it was, and here, well, and this is here only. It's pretty obvious if you look at that. You see the illicit movement. Yeah, so this is clear. This is a repetition, and now something new, and we make the positive. That's original work by myself recently, last year or 2 years away, but. If you have something like Martin is tall, yeah, and Martin is short, yeah, I mean, when you do such a thing, yeah, what counts, yeah, what counts as you see, what counts of shortness or tallness is heavily context dependent. So you always see this picture here, yeah, but I'm presumably the only one who have really made use of that, yeah. And I mean, usually you have the scale of increasing tallness, yeah, and in a particular context, yeah, you have here a neutral domain, yeah. Here are the things that are neither tall nor small, yeah, and for certain things we know they're tall, this so to speak the limbo, and for other things we know there are small. So small is not the same as not tall, of course, in one reading, because you see the not tall area would be that, yeah, and the not small area would be that, yeah. But you can't be not tall without being small, short, yeah, short. I'm always mixing here German here because we say klein, so the neutral domain, yeah, the neutral domain here, this S, if you have a scale, it heavily depends on the context, so it's clear if you have in mind elephants, yeah, and you say jumbo is small, yeah, jumbo is small, yeah, that could be, it's a large animal, yeah, but it's small, yeah, if we have in mind element, or if I say, for instance, so the I don't know, yeah, for certain buildings, so the Penang the Pan Am building is short, yeah, then presumably I have in mind very high buildings altogether, the skyscrapers, yeah, and so we don't have the Twin Towers anymore, but so others of these, so let's say the Chrysler building or the Empire State Building, these are still tall, but perhaps the Pan Am building is short. It's that. Well, and if you take flies, yeah, as you say, Fifi is a big fly, yeah. So you have the comparison class would be flies, yeah, and if you have those in mind, so Fifi can be big, yeah, it can be big, but of course Fifi is smaller than Jumbo, yeah, the elephant, that's clear. This already in Aristotle in the categories, yeah, he says that in the summer few peoples are in Athens, yeah, and many peoples are in Sunion or whatever it is, yeah. So, and of course there are much more people in Athens than in Sunion, yeah, what Aristotle says, yeah. In the, I don't know whether there's Sunion, Athens certainly, but then a smaller Megara or whatever, yeah. It heavens. Hopefully. Well, and therefore the neutral domain. Yeah. Thing is here, so the context, what it gives to you, somehow, depending on the scale, yeah, on the context, the neutral domain, that's a function that gives you something, yeah, that is not an interval of that scale here, that is not an initial interval, nor is it a finite interval. So it's somehow in the middle, of course not in the middle because the scale is infinite, so it starts somewhere below, so it's difficult to define, but that's it. And of course now you can define the positive operator, and the positive operator, what does it? Yeah, it takes you a set of degrees, yeah, it takes a set of degrees, a property of degrees, and it says, yeah, that every degree, yeah, it's that what is it here? Let me see. So the set of degree is true of every degree in the neutral domain, and you see. This told you if you look at height, yeah, if you look at height, for instance, if you say Martin is tall, yeah, it means, yeah, that in every degree within that interval here, so Martin is at least as tall as that, yeah. So that means, so Martin's height must be at least here, yeah, at least here. So he must. That's where the tall people start, yeah. So he must be here or me or higher, yeah. I mean so. And of course, if you take then the negative thing, you have exactly the same semantics. You have short, and recall that short is in some sense the complement of high. So so Mary. So this is an error here. It should of course be Mary. So Mary is short means, yeah, that. The height of Mary, yeah, it's smaller or equal of d, yeah, and for every d that's in that interval. So that Mary's height is at most here and presumably lower, yeah. So that gives you, so in other words, the positive operator, it's simply a universal quantifier that's restricted, a universal quantifier over degrees that is restricted to the neutral interval. That's it, yeah. I think that's like that, and a lot of people like Irena Heim, etc., have accepted that immediately. Mostly, the nice thing is here that you have a unified semantics, yeah, for the positives, for short and for tall. Yeah, it gives you, and of course you can have it if you have negation. Yeah, for instance, if it is neither short nor tall, yeah, you represent the neither nor somehow as neither, it's not that and not that. Yeah, that's neither. Yeah, and where you present it that way, it's not so that Ada is positively tall, and it's not so that Ada is positively short. Yeah? Recall, by the way, we are still with respect to the same scale. Yeah? So we don't. So we have that semantics here in terms of negation, complements. Yeah? So, and of course, if either is neither tall nor short, he's precisely in the neutral domain. Yeah? So it must be there. That comes out from the semantics. I think this is exactly right. Yeah? Now, short, we are in the syntax here, comparison with other account. I mentioned initially, it's a very good paper by Creswell. That's the first paper who analyzes R then as a generalized quantifier. Yeah, this is really the first serious logical syntax. I mean, there's other stuff by Bresnan, etc., Chomsky, but they never really interpreted stuff. So Creswell was the first, and what he did is this here. And, well, he had the Creswell's meaning of tall is already a degree. It's not, it gives you precisely the height, yeah, of, it applies to an object and a degree, if it is precisely height to that degree, so he hasn't built in monotonicity. But what's more important, he has defined the comparative as a sort of existential quantifier. You see, we have 2 degrees. Yeah, 2 degrees say that the first one is Mary's tallness. This is John's tallness, and he says then, well, there is a degree to which Mary is tall. There is a degree to which John is tall, but the second degree is higher than the second, and then the first. This, of course, okay, yeah, but I mean, you can advantage, but the criticism, or my criticism, was it's one of the few things, it can't account for negative polarity items in the then clause, yeah, because you see, we have Martin is taller than anybody else, yeah. That would, first of all, it doesn't license. Yeah? It doesn't license the negative polarity item because we need a downward entailing context. And you see, here's the repetition of the downward entailing context, yeah, following Ladouceur. So it's, in that particular case, if we have 2 sets that are in the subset, subset relation, we have an operator like negation, for instance, and if we apply an operator, this operator F, yeah, to some of these sets, and we say here A is a subset of B, then for instance F of A, and then F of B, that's the bigger one, should entail F of A. Negation would be typically a downward entailing operator, but others, one like no one, and perhaps negative quantifier, a few also, they're all downward entailing. And this certainly, the existential quantifier, it's easy to show it's not a downward entailing context. And what is worse, it also gives you wrong readings. For instance, I mean, Ladouceur, I mean, it's the standard meaning of anybody. Anybody means the same as somebody, so it's simply an existential quantifier. So what Creswell's semantic predicts here, Martin is taller than anybody else, means Martin is taller than somebody else. Yeah? But this is, of course, not what it means. I mean, Martin is taller than anybody else means he's taller than every other person, yeah, or than any other person, yeah. And so that's wrong. Yeah, it couldn't be. And Søren, this is also quoted a lot, is has an extent semantics, yeah, but it's never spelled out, yeah, in a reasonable way in semantics, but people have attributed. I mean, so the analysis. So what we find in Søren is simply this here. Taller is represented as there is an extent, John is tall to extent E, and Mary is not tall to the extent E. And well, people usually say that they translate that into degrees. Yeah, you find that always in the literature, but I don't think that's quite exactly CERN's intentions. But you could do it then, and you could say then, well, the comparative would be there is a degree. Yeah, so the main clause. So what's expressed by the main clause instantiates that degree, and what's expressed by the then clause doesn't instant that degree. So that means there is a degree of tallness, so John is taller than Mary would be. There's a degree of tallness that John has and Mary doesn't. Yeah? This is fine, yeah, if you do it that way. And it's also good. It would give you also license also NPIs. So, for instance, Mary is taller than everybody else, would mean, yeah, there is a degree of tallness. Mary has it, and it's not the case that someone who is different from Mary has it, and that's precisely right. Yeah, so that is a reasonable account. Yeah, if we did it that way. It's not quite, I think, what it's not exactly the right formalization of CERN, because CERN definitely has in mind extents. Yeah, I have that idea that we have intervals and extent, and so one really should formalize CERN's idea in a more complicated way, namely something like that here, what is written here under ER. So we have new thing, what is an extent, what should be an extent. An extent should be, of course, either an initial segment of a scale or a finite segment of the scale, of the degree scale. So I give it here a new type, and then certain semantics would be that. And then we would have to represent the meanings of the adjectives. That gives you an extent. You see, we have here this would be the extent argument, yeah, and that would be the subject. And we would say so that every degree, we might have two that are in the extent. So the height of the subject is taller or equal to that degree. Yeah, and if we use that here, yeah, I mean it's nothing in CERN. Yeah, that's my own reconstruction. If we do it that way, we can use that semantics here, and we would have then John is taller than Mary. We have that formula here. You see that we have a universal quantification, and you see here. So every degree, yeah, that goes up to the actual height of John, that is in an initial segment of the degree scale. Yeah, there is such a degree. Such a segment, but there is no such segment for that goes up to, but not for every, but in that particular extent, not for every degree that goes up to the height of Mary, and this is true, and this must be, and therefore, the heights of Mary must be smaller. If you calculate of that, so that's a way of formulating it. It's not done in the literature, but could do it that way. Kennedy, yeah, I told you that for Kennedy, he's very proud of that. He says that an adjective simply maps an individual into a degree, or perhaps into an extent. And of course, then we have to ask ourselves, what does it mean that Mary is tall? Yeah? That Mary is tall. Then he introduces an operator, which I have called here a positive operator, but he calls that absolute. Yeah? So it's the absolute reading, an absolute reading, not the relative reading. And what does it do? It's a relation between two degrees, yeah, and says that the second degree it's smaller or equal than the first one. And I tell you what it is. The idea is if you have John is tall, yeah, so the context for tallness gives you in the neutral domain. If you have that neutral domain, it gives you the standard, I've called it here S plus, from which, so we have here, that's my neutral domain. This Kennedys have S plus, and here we have S minus. So here, in a way, the tall things start. Yeah? And then an absolute tall John to degree S means that the height of John is bigger or equal S plus. So it's the same as I had, and you have to stipulate another coordinate by the context for short things. Yeah? So, and you have to introduce this here. Yeah? And this, of course, I mean, there's a bit of more stipulation than in my approach, because you have to stipulate two things. Yeah? You have to stipulate 1 degree for the positive adjectives and another one for shortness for the negative adjectives. You have to get that right. Yeah? I mean, this is here, if you now have a representation of John is tall, so the easiest thing would be to represent it here somehow in the way I've did it, but I only want to mention, if you look into the dissertation and later work by Kennedy, the syntax is extremely complicated. Yeah? So what he does is something like that. You can check that then and think. So he has an adjective. Yeah? Here he has an empty operator that's provided by the context, and here you have a spot in the degree phrase. So it comes, so to speak, the coordinate that gives you the limit, the delimitation between the not tall and the tall things. And then you have a very complicated operator and a sort of combinator. Yeah? And this is people who have were in the talk of at Stabler, you know what combinator is. It's such a function that contains no free variable, yeah, and somehow shifts type. If you calculate that, you get the right thing, and this is the easiest of these operators. That's all, I mean, for the empty places. And what he does, yeah, I mean, when he reconstructs the deletion, yeah, into the gaps, he always fills the operators, yeah, in a way. They can be that long, really, yeah, and you can do, you can spend half a morning in calculating, yeah, so that things come out, yeah. I mean, and so so if you look at that, it's at first it looks simple, but if you go to more complicated cases, you see it's incredibly hacking, yeah, and that, so it's basically, the point is that you see you need it here, and even it's more clearer when you go to Russell's ambiguity. You can really see that it's not enough to regard adjectives as measure functions that map objects into degrees, yeah, or set of degrees. It's you also there must be relations. There must be relations. You see it that you need it here, even for positive statements, and you see it also here. For instance, in when you represent the consistent reading in Kennedy's approach, I thought your yard was longer than it is. Yeah? I mean, you see what you do here, where you had the free variable delivered by the context, yeah, that gives you the delimitation for the big things. You have a bound variable, a degree variable d at that position, and here of course, you think you have the set of degrees, yeah, that such that in all the worlds of your thinking, they go up to the height of the yard there, yeah, and I mean, and this is a very simplified LF here. Kennedy doesn't that way. It's that long actually, and you see it, yeah. That's no other way of represent it, yeah. That you also need here the absolute operator and that degree here. So it's always the case here. If you start from very simple examples, yeah, where we started from the beginning, so the duck weighs 2 kilos, etc., you can get along with the simple syntax. But if you go to with simple semantics to more complicated examples, you see you see it, that you need actually a semantics that makes an adjective a relation between individuals and degrees. You see that. Yeah? And Kennedy needs it too. And he then introduces the absolute operator. Okay. So that you can study a bit, and here I have, you can read something. If you go, if you accommodate all that stuff to intervals, it's more complicated. So this is the repetition of syntax. So we go now to cover a bit of ground, and we go to section 3, and look at quantifiers and then clauses. Okay. Okay, right. Now, you see, I start here with some, I've mentioned here some literature, and the topic, I mean, it was already discussed, some of the examples in my original papers. For some of the examples, I did it right. I introduced the max operator. But there are serious problems because there are many cases where I had to scope, we see in a moment why, the quantifiers in the then clause, and had to outscope them. And the topic was brought up again by a paper by Schwarzschild and Wilkinson. No one can understand that, included me for some reason, and Irene Heim has then retranslated it into something you can understand, but it's of course, I mean, in some sense, everything is correct, but it's for some reason or other, it's represented in a way you can't understand it. So what I do here, represent first the theory in Heim's words, that I can understand. And Schwarzschild's my friend, but I spent really, and like other people's, 2 weeks, etc. I didn't master it, so I find it hopeless. And some people can do it, And the observation is this here. You see, if we start with sentences like Martin is taller than anybody else, normally we say QR is clause bound. We know we can't QR out of a relative clause. That would give you a lot of nonsense and shouldn't. QR generally should respect clause boundedness, so you shouldn't go out of a finite clause. But what is worth, you shouldn't. I mean, you should leave it in place. And the point is, if you take anybody else, and you mean somebody different from Martin, and you leave it in the then clause, you get the wrong reading. Namely, have a look at that. So we have here we have Martin, and here we have two other peoples, A and B, Anna and Berth or whatever, And here we have, now we have, you look, if we leave it in place, we have it that the actual height, I don't have the word parameter here, it's not so important, of Martin, So this is the actual height of Martin, and the actual word goes up to here, And we, then everybody, then anybody else. Okay. Now this is fine. And this is fine. And then we have anybody else. That's an existential quantifier, and we take the set of degrees that there is such one. That's different from Marty, and the height of that people and those degrees go up to the heights of that man. Well, you take, of course, there's someone, you take the bigger one, so the taller one of the two, so the set of degrees go up to here, and here we have Martin, so this is fine. So if we have something like anybody in the then clause, it gives you the correct reading, the point is, if you have as an existential quantifier, yeah, and you say taller than anybody else as an existential quantifier, you have several people, you always go up to the tallest person. Yeah, that gives you a max reading. If you forget that, because if there is one and you have to go, there is one. Yeah, of course you have to choose the tallest one. Yeah, since there is one. Well, now the thing is, and same thing, I'm stronger than I was ever before. Yeah, ever before. So what means ever before? I mean, ever before means there is some time before the time where we are. Yeah, that's ever. Sometime before, and this is also correct. You say this is the strength the set of degree, the strength I have now, yeah, at the actual moment, yeah, and those are all the degrees of the strength. There's a time before now, and I had my strength at that time before now was that. So all the degrees that of strength that went up to the strength I had at that time. Therefore, it's an existential quantifier. You have to be the biggest interval. Yeah? You'd have the biggest interval of all these, and this perfectly right, because I'm stronger than ever before means there was no time before said where I was as strong as I'm now, yeah? Right? And so this is okay. So that's the first generalization. Everything is fine for NPIs. Yeah? Now, more examples here. It's always the same point, so nothing new. I'm busier than I was ever before. He's richer than you care to know. Yeah? He stole more than he has confessed yet. And sie ist reicher als auch nur ahnt. It's German. And, well, okay. And now we come to something that might be called strong quantifiers, or I simply call it at the moment positive quantifiers to distinguish it from NPIs. And if I say I'm stronger than everyone else, yeah? I mean, you see, the scenario is this, yeah? I mean, this is a small scenario, but there are two people that are different from me, and I'm stronger than everybody else intuitively. That would be a good scenario. I should be stronger than the strongest of the other people. Yeah, that's right. I think we all agree this must be so. And if we have that scenario, if from the two other peoples one is stronger than me, yeah, I think intuitively the sentence is false. Yeah, we agree on that. Yeah, okay. Yeah, so I'm stronger than everyone else is. But if you look now, yeah, the problem is, yeah, if we take the narrow scope, yeah, if we take the narrow scope and take that one, and the point is we always go to the smallest people, yeah, because if we look what it is, yeah, if we look what it is here, here, and here the quantifier, everyone different from me, I take the set of degrees that everyone that's different from me has, yeah. So I go by downward monotonicity. I must go to the common degrees, yeah. Of course, if I have two people, one is 1.90 meter and 1.80 meter tall, the other one is only 1.60 meter tall, so the degree they have in common, yeah, so the highest degree is only 1.60 meter, yeah, it's clear, yeah, because the smaller one of the two people isn't 1.80 meter tall, yeah, therefore you have to go to the smaller one of the two, so the degrees, and what you have then, that this means I'm stronger than the smallest, yeah, of the other people, yeah, and this is not what the sentence means, yeah, it predicts you that this is an entailment, it's true, but it's not, but it would say that the sentence is true in this scenario here, yeah, because here I'm of course I'm of course taller than the smallest of the other people, yeah, the shortest of the other people, and this is not what I want. So that's a wrong prediction. Yeah? I mean, the same thing here. Right. So in other words, yeah, in other words, this here, they must have. The correct reading is we must give the quantifier matrix scope. Yeah? If we scope out, so for everybody else, everyone is different from me, I scope it out by QR out of the entire comparative construction. I have it, of course, for every person that's different from me. Yeah? So the strength of that person, it's a proper subset of my strength, so all the degrees that go up to my strength, and this is correct. Yeah, so this is correct. So you obligatorily you have to scope it out. Yeah, otherwise, so you have to. That's the problem, and you have to do long QR. Yeah, and the same thing. For instance, I mean when originally in my old paper I had in mind, I thought that for indefinite quantifiers they stay below, and in a lot of cases this is also true. If I say I'm stronger than a student, then a friend, then another man, yeah, then another man. So it might have a generic reading, yeah. So it could mean, yeah, any other man. But for instance, if you can enforce, yeah, wide scope. For instance, if you take Martin is taller than one of my friends, yeah. So certainly it doesn't mean that he's taller than every one of my friends. Yeah? So I have to. There's one particular of my friends, such that Martin is taller than him, that might actually be the shortest of my friends. Yeah, and this might be the shortest of my friends. Yeah, but then I have to, in order to get that here, I have to scope it out. Yeah, this is this scenario here. Yeah, and also apply long QR. Yeah, when same thing here. In order, you have to appreciate that. So Martin is cleverer than many linguists. Yeah? So what means many linguists? So for instance, let's say something like Kennedy, we have a cardinality of the group of the linguists, and what many are, it's somehow determined by the context. So we have here a number that is that is determined by the context here. And the narrow scope reading, he's cleverer than many linguists, means that there is a set of linguists that has some cardinality, that salient cardinality over the standard by many calls, and for every those Martin is stronger, but certainly we don't want to have that. We want, for many linguists, this is the case. Yeah, for many linguists, it is the case that Martin is stronger than these. Yeah, I mean, if you maybe I make the point. These are tricky. These are tricky. I make the point. I give you an example. So, Olga is taller than most girls. Yeah? Olga is taller than most girls. So what is most? Standard in generalized quantifier theory, most is usually done and said, and I don't think this is correct, but here for these purposes it is. Most girls means, so most girls are tall, that the girls, you take the cardinalities of the girls intersected with the tall things, and those are more, it's a bigger cardinality than half of the girls. Yeah, that's the usual meaning of universal quantifier. And if you look at that, you take the narrow scope reading, and Martin is taller than most girls. Well, what is it? Yeah, you see here, have a look at scenario. It's always good to look at a scenario where you have very few people. So we have Olga, and that's the one we are talking about. We have 3 girls, A, B, C. In this scenario here, we certainly want that it is true. Yeah, here is Olga. It's taller than most of the girls because the majority, she's taller than A and B, and that's the majority of the 3 girls, A, B, C. Clear? Huh? Okay, so we want this to be true, and this is the height of Olga. Yeah? And now the majority, the majority reading of most girls. Yeah. So the degrees. Yeah. That. Always puzzling. I have to look at that. So the set of degrees. Yeah. So that goes up to most girls. I say it's this one. Yeah, it's this one. This we have to calculate. Yeah, this I'm always puzzled. I should give you an argument why this is so. I'm pretty sure this is correct. Yeah, and all right. If this here, yeah, right. Yeah, in a sort, in some sense, yeah, this is a positive quantifier. This is an existential quantifier. Yeah, this is an existential quantifier. We have done it here, and most girls, whatever it is, we have to go. We have to go to the highest of the girls. Yeah, to the highest of the girls. So we go to the tallest of the girls. We go up to the girl C. So we get this set of degrees. But you see, of course, that if you look at the semantics here, this comes out wrong because this here, Olga should be taller than most of the girls. Yeah, this set should be a proper subset of this here, but this is not the case. Yeah, so this comes out wrong. Yeah, in this scenario here, if we take it narrow scope, if we take it wide scope, yeah, it's correct again. Yeah, because for most of the girls, yeah, if we take most of the girls, we quantify over the girls, yeah, then we have it here that Martin is taller than these. Yeah, this is, by the way, maybe not a very clear exposition. These are tricky things to convince himself. I haven't thought of that at the moment, but I think these formulas are precisely correct. I would have to think a moment to see why this is so. Yeah, and so this is also wrong. And the same thing is with exactly of 2 of the others. So Hubert was taller than exactly 2 of the others were. So what so what we want to have here is that for exactly 2 of the other people, so different from Hubert, Hubert is taller than each of those, and this other example here. And the problem is, I mean, you convince yourself looking a bit at the examples that you only get the right reading if you have a positive or this strong quantifier. You scope it out of the then clause. Yeah? If you leave it there, you always get the wrong reading. Yeah? So this is really a very bad thing because we have, so to speak, reached an impasse, and we have to QR it out. Yeah? And well, this violates, of course, close-boundedness, and the bad thing is, well, maybe we could leave it there, but if we leave it there, yeah, we get the wrong reading, yeah, and the easier way of generating the thing, yeah, so to leave it really under in the scope of the comparative, yeah, the easier way gets the wrong thing. That's even worse. Yeah? So that's not a good result. Yeah? Now we come to negative quantifier. My old theory was done for negative quantifiers and did it quite well. If we have sentences like Sveta is taller than nobody else, yeah? This is in a way plain nonsense. Yeah? I think no one understands that. Yeah? And of course, if we could scope it out here, yeah, we could scope it out the nobody else of the then clause, we would have it for nobody that's different from Sveta, and we have it that Sveta is taller than he. Yeah, this perfectly okay. Yeah, it should be so. Intuitively, a negative quantifier in the then clause is plain rubbish. Yeah, but if we outscoped it, yeah, as we had to do for the positive quantifiers, we get nonsense. Yeah, that's another very bad result. Yeah, and same thing here. I'm stronger than never before. Yeah, so that we don't understand either. Yeah, then, for instance, if you have downward entailing quantifier, so Martin is taller than few students, it's not clear what it means. But it would have a good meaning in the matrix scope, but even, again, nonsense, yeah, Martin is stronger than the few students. Yeah, I think you agree. I mean, if we hear that, yeah, we try to understand it, but we are really not sure what to make about that. Yeah, so if we have that intuitive, I think, I mean, perhaps you're strong thinkers and say, well, it means that, and then you convince yourself you're very sure it means that. Yeah, but it certainly would take a long effort, yeah, and to make sense of that. His fewer, of course, you could extract it for matrix scope. It would mean for less than half of the students we have it that for less than half of the students that Martin is stronger than them. Yeah, and so that would it mean if it had matrix scope, but presumably we don't get that reading. So the generalization is we have to do that negative quantifiers, yeah, make no sense in then clauses. Yeah? So right. Yeah? And frequency adverbs. Yeah? Frequency adverb, if we say, for instance, it's warmer, basically the same characteristics. It's warmer here today than it usually is in New Brunswick. Yeah? Or let's say here, to formalize it, so it's warmer in Stony Brooks today than it usually is in New Brunswick. Yeah? It means, if you look at the second here, so for most times T, it's warmer in Stony Brook today than it is in New Brunswick at T, right? Yeah, and it doesn't mean, it's warmer to a degree that New Brunswick reaches at most half of the time. Yeah, that you would get if the thing usually had narrow scope. So the point is also, you see that the adverb of frequency intuitively also has wide scope over the matrix, yeah? And this adverb of frequency, though it's pretty clear that we can't even move adverbs. Yeah? So how could we move adverbs? Yeah? It's not the slightest idea what DLF could be. Yeah? So the idea is that positive frequency adverbs have matrix scope, but if you look at negative adverbs of quantification, I've gone here to German because I'm not so sure in English. So if don't ask people. So if you say in Oslo, es ist niemals wärmer als in Konstanz heute. In Oslo, it is never warmer than in Konstanz today. That's fine. Yeah, it's in the matrix. Yeah, but for instance, if you say es ist heute in Konstanz wärmer als niemals in Oslo, yeah, that's plain rubbish. Yeah, so it's today in Konstanz warmer than never in Oslo. Yeah, so we don't understand it. Yeah, so we have here the same problem, and the same thing if we go as something but seldom. Yeah, it is in Oslo is seldom warmer than it is in Constance. Yeah, this is fine. But if we have, for instance, the 22 today, it's warmer in Oslo than seldom in Constance. That we don't understand. Yeah, and seldom it's something. It's a downward entailing frequency adverbs like few times, yeah, and we simply don't understand it, yeah, if it's in the then clause, yeah. So what is the outcome or the conclusion of all that? So negative frequency adverb make no sense in then clauses, yeah, but they are good in the main clause, yeah, and you see. We could try for the other things here with dp quantifiers. We could try to solve this somehow by imposing restrictions on QR. Yeah, we have to do qualifications, yeah, whether they're positive or negative, NPIs, and so on. And say, for instance, for positive quantifiers, we have to outscope them in a certain right. But here with the adverbs, yeah. That seems to be impossible, yeah, because we couldn't. We basically find the same diagnostics, yeah, for the adverbs, but an adverb couldn't move, yeah, because what could be the trace or whatever of the adverb? There's no way, yeah. The adverb doesn't have scope, yeah, in that respect. So that's no. It's not good idea, yeah, to do it. And now with modals, basically similar findings, yeah. There's only a very few modals, namely epistemic modals, yeah, that seem to take a matrix scope when they occur in the then clause. And if you have it's warmer today, then it might be tomorrow, yeah. So that means, yeah, that might, yeah, might, could. There is a possible word, W, such as warmer in the actual word than in W tomorrow, yeah. And what does it mean, yeah? Possibly it's colder tomorrow than it is today. Doesn't mean that this is compatible. I mean, with that scenario, it is compatible. It might be, yeah. It's warmer today than it might be tomorrow. Yeah, that doesn't exclude that it's possible that's colder tomorrow. Yeah? It might be warmer. Yeah, could be colder. Yeah? And so we couldn't. I mean, you see, if we have a narrow scope, if we leave, yeah, you see, the might occurs in the then clause, yeah, and modals. Modal verb don't move. Yeah, how could in the LF? How could verbs move? Yeah, it couldn't change the meaning. We had movement. Yeah, and so suppose we gave the modal narrow scope. Yeah, there would be something. And so the set of degrees. So lambda d. Yeah, the set of degrees d. Such possible. It might. There is a word. Yeah. There is an accessible word, yeah. So the temperature tomorrow in that accessible word, so all the degrees that go up to the temperature, it's a proper subset of the temperature today, yeah. But this, of course, means, yeah, that we go to the maximum. We go to the maximum because we have an existential quantifier, yeah, in the scope of this Lambda operator. So we must go to the maximum of these degrees. It's an existential quantifier, and therefore, it's of course not possible that's warmer tomorrow than today. Yeah, and this is not what the sentence means here. If you look at that, you convince yourself, yeah, this is a bit of tricky reasoning, but it's obvious. Yeah? I mean, the same thing here. It's Irene Heim. Look with the secretary. John is more polite than his secretary must have been. Yeah, John is more polite than his secretary supported, yeah, to have been. So, if this means, yeah, this means so in every accessible word, yeah, John is more polite, yeah, John is more polite, than his secretary. That's an error here. So then. then is more polite than a secretary in the actual world. So it's the actual word. So this is wrong here. Secretary is in the actual word. Is it does, if you leave it, if the adverb had narrow scope, we would go to the smallest degree of politeness, and so it would mean something that John's politeness exceeds the minimal politeness, and we would have expect from his secretary. So he just behaved a little bit better than the secretary. This is not what the sentence means. So again, we have this has here wide scope, but and that's the last thing I want to say. Most modals, have in fact narrow scope with respect to the then clause. So, for instance, he was more cautious than he needed to be. There, it's possible that, for instance, it would have been okay had he been less cautious. It does not mean it would have been necessary that he be less cautious. That he be okay. If we get precisely the right reading, if we leave here the necessity in the scope of the ER, because then we go to the smallest degree of required cautiousness. And if we have another thing, he charged more than he was allowed to. That's another typical case, or he charged more than allowed, and he charged more than was legitimate. Here, again, we get the right thing if we leave the modal in place in the then clause, because this is an existential quantifier, and so there is an accessible word that fulfills the requirements, and therefore, you see, he's allowed, for instance, the maximum he's allowed to charge 20 euros. That's the maximum. But he charged more than he was allowed to. That would be true if he charged 30 euros. So we have to go to the maximum. This is precisely right. So the intermediate conclusion, where we start, we have a bit lost time here because of this fire break. So not to blame for that, and leave that. One of the problems is here, no ambiguity for the quantifiers, adverbs, etc. is observed. So we shouldn't account for these things in terms of different movement. So that's very unlikely to do it. And frequency adverbs and modal exhibit more or less the same scope behavior. So some of them take wide scope, others take narrow scope, and of course we still negative things never make sense in the then clause. We have to account for that as well. And so the conclusion seems to be all these things somehow have to interpret it in situ. It seems to be, but somewhere we have to make structural differences, because how could we account, for instance, with these modals and frequency adverb for the different scope behavior? This is now, we're really at the core of a very, very hard problem. That's much in the current debate, and there I will finish. Here that you have to read, also the rest of the paper. Now it becomes, of course. So I think we should start. Someone else will come sooner or later. So let me repeat. I wanted to make cover a bit more material last time, but there were the 20 minutes that were missing. So let me repeat where we are and where we will go. I mean, at the end of this at the end of this course, you will be more or less on the stage, so of the actual stage of research. So you have every method available to solve problem, and I'm actually now presenting theories of quantifiers and then clauses, and none of those will work. Actually prepared the handout of Sigrid Beck, that's the news, and they didn't bring it, but it's on the web, so I projected, you can load it down, and I tell you at the end what's wrong with that. I calculated it my night, and I thought, usually stuff of Sigrid are okay, but when you go to higher order things, you have to really count, and you have to calculate everything, because it's very easy to make errors with non-standard quantifiers. And there's one, let me repeat, I made one myself, and because I calculated a bit tonight, and tell you what, let me first repeat what we have. When we have a quantifier, we have basically four different cases. And when we have a quantifier in a then clause, so John is taller than anyone else. This is an NPI, and this gives the right prediction under the actual theory. It tells you the anyone else. It's an existential quantifier. It means it's a person different, from the person we are talking. That's so different from Martin, and that gives you the set of degrees that gives you the highest of those person. You make it relative, they go up to the highest of this person, so that will then anyone else give you the correct meaning. When you have same thing with ever and so on. On the other hand, there are other quantifiers which I have addressed as positive quantifiers. So something like every girl, most girls, etc. So I've said something wrong. With most, it's still more complicated. So let's take every girl or one of my friends. These are not correctly interpreted under the current theory when they are in the then clause, because John is taller than every girl will give you the set of degrees that go up to the smallest of the girls, because it's a set of degrees that all the girls have in common. So you intersect these, so to speak, and you go up to the smallest girl. And so this is wrong. But the same thing, so Martin is taller than one of my friends. One of my friends, the same problem, you see, that might be actually be the smallest of my friends, doesn't matter. But in any case, in that particular case, you also get the wrong reading. You get the right reading for these positive quantifiers if you scope them out of the then clause, so you have to stipulate that. And we'll see in a moment that we shouldn't do that. So that's the other finding. So then, if we go to negative quantifiers, so it's something like no girl or never and so on. Maybe few girls, and these the fewest girls. These don't make sense in the then clause, and we have we have Martin is taller. You wanted to say something? No. Martin is taller than no girl. We simply don't understand it, and this is predicted by the current theories because the set of all degrees, that go up to the highest of no girl, has no has no maximum, and so you couldn't. It gives you a final segment, of a scale, and Martin couldn't. And Martin's height occupies an initial segment, Martin's tallness, and so you couldn't compare these. This is predicted as well, and so you could perhaps stipulate that negative quantifiers, etc., don't scope out of the then clause, yeah. But then we have more problems if we came to the adverbs, yeah, adverbs of frequency, yeah. We had basically the same diagnostics. There were adverbs that had to stay in the then clause. For instance, I'm stronger than ever before, yeah. So ever means at some time, yeah. And if it stays that in the then clause, you give you take off all the times, the times where you have reached the highest strength, so it's an existential quantifiers, and that gives you, again, the correct reading for the end pair. But for instance, if you have something like it's warmer today than it's warmer today in Paris than it is usually in Constance or whatever, that doesn't make sense if we leave it down. Yeah, I don't want to repeat that. It's a bit tricky, so we have to scope it out, but we couldn't scope it out, yeah, because how to do it? Yeah, I mean, if you try to scope out an adverb, you simply don't know how to do it. Yeah, I mean, so basically adverbs don't move, and the same thing with negative adverbs of frequency, like never, no times. So it's warmer today than never. It's also plain rubbish. Yeah. So so the same thing. So here we couldn't work with stipulation and movement, and we had the same diagnostics with modals. Most of the modals stay down in the then clause, so the paper is longer than required. Yeah, so it means its actual length is above of the minimum of the required length, and the minimum you get, we have the universal quantifier over words, yeah, and there, so to speak, you take you take all the deontic words and look what the length of the papers are there, and you look at the common length and what they have in common, so you go to the shortest length. This is again okay, yeah, but and there is same thing with he spent more or he charged more than allowed. It's also fine. It gives you a maximum reading, and again another problem with there is an exception with epistemic modals. Yeah, epistemic modals, we know they always have widest scope. Yeah, you couldn't negate an epistemic modal somehow. Yeah, so like epistemic adverbs, yeah, you couldn't negate, yeah? Like certainly or so on, you couldn't negate. And in the sentence, and here we have it, so, or there was a sentence like, so it's warmer today than it might be tomorrow. So basically, you have to scope out that adverb, and you say there is a possible word, yeah, where it is warmer today than it is warm in the actual world. Yeah, the same diagnostic, and here, of course, with modals is even worse. How could you scope a modal itself? Yeah, and a modal has a fixed place as a verb. Yeah, and it doesn't move. Yeah, it moves in the syntax, perhaps. Yeah, if you have V2 movement, yeah, in German and other languages, but this is semantically completely inert. Yeah, it doesn't affect the meaning at all. Yeah, so there is that's where we are, and I have to say something. I have made an error, and this is also instructive. Looking, can you remember that I was puzzled a moment when I looked at the sentence "Olga is taller than most of the girls," and I said when most of the girls has narrow scope, it stays in the then clause. Then it's if we have the girls A, B, C, yeah, and then it's the degree that go up to the C that's actually wrong. Yeah, it's even worse than that. If you, I won't calculate that now. Yeah, but one of these typical errors. It's actually even worse. It's the negative segment that starts with the sea with the tallest girls and go up, and goes up to infinity. Yeah, I won't give you the calculation. I've convinced myself, but I said it's bad and it makes the wrong prediction. It's even, if you leave it in the scope of the then clause, it's not even interpretable. Yeah, it's even incorrect. But this is one of the typical things where one really has to be very careful when we come to non-standard quantifiers and look very carefully what happens. Yeah, that's difficult. I made an error here, and many other people do. Irena Heim never does, yeah, but she's always very careful. But other people who work about these things, so don't, even in published stuff, yeah, don't take things for granted when it comes to higher order. Yeah, you will find many errors. Yeah, because it's if you don't calculate these things, we don't have the slightest intuitions. Yeah, and so we have intuitions about first orders, the quantifications. Yeah, that we can do easily. If you go higher up, yeah, we have to be very careful. Yeah, so I'm okay now. I said, well, with negative quantifiers, well, the thing is, that's the resume, so nothing works in a way, and we have to do something to account for this difference. So I first present here the theory, what it's called by what's that? Yeah. I first present the theory by that Heim calls in her salt paper the Lasnik-Schwarzschild-Wilkinson theory. The Schwarzschild paper is on my handout. You can write down. Unreadable. Maybe you're cleverer than I am. And there was a certain stage here where I understood it, and then I couldn't remember it, yeah? And this is a very bad sign. But I can more or less remember what Heim said about. Yeah, so I take it, and she attributes that all to Schwarzschild. But if you really want to work about that, you have to read it. There's nothing wrong with that paper. Of course, it doesn't work. Yeah? But I mean, technically, it's okay. And so the basic idea is this, yeah. If people don't get along, what do? They do a sort of type shift. They raise a bit, yeah. I tell you one thing: you should never do that if you don't must, yeah? Because as I told you, if you go higher up into second or third order logic, etc., we lose all of our intuitions, and the thing might mean something very different from what we thought. Yeah. So the raising the adjective, it's simply this here. You see, first, yeah, the adjective, the first degree, the first argument of the adjective was a degree. The second argument was a subject. Yeah, and we said, well, the height of the subject, yeah, is at least it's taller or equal that degree. Now it's different. We take here sets of degrees. Could be any set. Schwarzschild calls them intervals, yeah, but that's not quite correct. Yeah, there could be any scattered degrees, set of degrees, and it simply said, yeah, that the height of the subject is in that set. Yeah, it's simply that. Yeah, and if you look at that, if, for instance, if you fill, yeah, if you look at the type here, so the big D is actually, it's short, yeah, for a function that goes from a function of the type dt. Yeah, so it's here. So I've written it that way. So it's a property of degrees, and you see, if you plug in John, yeah, if you plug in John at the point of x, yeah, you see that immediately that you have a generalized quantifiers, yeah, because then, for instance, it would, if the x were not there, if this were saturated, yeah, then the entire thing would be a generalized quantifier that maps simply sets of degrees to truth values, right? Yeah. So that's, and you combine that now, and you take again the simplest meaning of the comparative, and simply say, well, your comparative is the relation between two degrees. We know already now after the lecture what they are, classes, yeah. and one degree is bigger than the other one. Yeah? So the second one is bigger than the first. Yeah? It's all Schönwinkelized, or as the American says, like Stabler, currified. Schönwinkel invented that. It's 1924. Now, you see, now we have to look, we derive a bit the syntax. The syntax cannot be the same anymore, yeah, because we have a type clash. Yeah? And if you look at that syntax here, you see we have here the comparative. If you look at the type of comparative, wants a degree, but it has here at the object position, yeah, that's the DEC phrase, it has a generalized quantifier, because then the then phrase, yes, yeah, I should say, well, it's generate in the usual way. The only thing that the degree variable now ranges over sets, yeah, and so it's a higher order thing. And then we have the main clause, and here we have a type clash. We have a type clash, yeah, at this object position, and so that we have to remove. Note, if we have removed it, we have no type clash with the main clause, because the main clause, now the other way around, takes a set of degrees, yeah, and if we somehow have removed the type clash, perhaps we can apply the main clause to the rest. Yeah. Now, look at the derivation. It's a bit tricky, and it will become more tricky in the course of this lecture here. And so the first thing is we remove the type clash by QRing, like always, and we QR the DEC P. The DEC P, so this is the surface structure here. So Martin is R, yeah, then every girl is tall, yeah. Now we QR, yeah, the DEC P, and we have this thing here, and what we do here, wait a moment, yeah, exactly, yeah. So we leave, then, wait a moment. Well, that's the first step, yeah. That's the first step that we always do. We first QR here, we first QR the DEC phrase. So this is not problematic, yeah. And we leave a trace here of this higher order type, so it's a set of degrees, and we have and we have the ER thing here. Yeah, so that's fine at the moment. That we did before, yeah, to give the degree phrase scope. But then, yeah, now now if we study that, we have the type clash here. Yeah, it's what I said before. Yeah, so the complement, yeah, the complement of ER wants a D, but here we have a DT. We have a generalized quantifier. Therefore, of course, we QR the entire then clause and go out of the construction. That's the next step, yeah, and remove the type clash. And in the next step, you see the LF we have got. It's a then clause. Then every girl is D tall. This is a generalized quantifier. Yeah, we leave now. Yeah, that's important. This movement leaves a trace of type D of the lower order. Yeah, to remove it. Yeah, that's important here. It gives it scope. You see the ER, and the DEC phrase the ER has a variable of the lower order type, yeah, and this, of course, and now, if you look at that here, yeah, it's a bit tricky, and you look the DEC phrase here, yeah, and the ER, that bit here, the entire thing is of type DT, yeah. You see, because one of the argument, the ER, yeah, takes it's the object a D argument. If this is saturated, you are left, so to speak, with an intransitive predicate. You have something of DT, yeah? And you see, now we have the right type. We could simply apply the main clause, yeah, the main clause to that thing here. You see it, yeah? That's the right type, and still inside, yeah, inside in the ER, yeah, and in the ER phrase, we have a degree variable. This is bound here by the then clause, yeah, and so we can apply the entire then clause to that construction. So, and I do it a bit here syntactically. So what you do here, you see, the next step in the calculation, we apply functional application of the main clause, yeah, of the main clause. That's the entire thing here. To what I said, yeah, to this deck pay inside here, yeah, inside. So what you see here, by functional application, this entire thing, yeah, goes inside to that d, and this lambda d disappears. Yeah, that you see, that's the next step. Yeah, and then you see now we have the right configuration. We have the right configuration for applying the then phrase to what we have. Yeah, and to what we have. Yeah, also functional application. Yeah, and we get every girl. Yeah. Every girl has the property that the property Martin is more than it tall. Yeah? And now we calculate this. That it's confusing. Yeah, I mean, but it's completely mechanical in a way, the derivation. But let's see how what the meaning is. Yeah, and that it's the right thing. You see here, if we look here at this is the main clause with ER at the degree position. Yeah, so Martin is R than D tall with the lambda abstract. Yeah, with the lambda abstract, and what we have here, yeah, you see it's a lambda D. The height of Martin is an element. You see. An element of this set here, lambda d prime is bigger than d. Yeah, this d here, yeah, is bound from outside. Yeah, and you see it here. Of course, Martin is an element, and we can now remove this lambda operator, and this binds that first variable and get it into the first place, and this makes it a lambda d. The height of Martin is bigger than d, right? So this comes out here from the main clause, yeah. And now we go now we look at the more complicated thing here. Martin is R is well, what means tall, and what means tall, being more tall than Martin is tall, yeah? And I mean, so we have the entire thing here inserted at the adjective position, and we get here, we have, you see, the height, yeah, of the subject, yeah, and here, what we do here, wait a moment, what is, yeah, that's Martin. Yeah, Martin, wait a moment. Yeah, here, well, that's, wait a moment. So here, it's also tricky here in, this here, this is a degree phrase, and this is a set. Yeah, this is of this is a quantifier. What is that? This is the property, and this is the property. You see, how should I say it in plain words? Yeah, it's what is abstracted here. what is abstracted here is what is abstracted here is the degree phrase that's bound here, and now we have it inserted it in the verb. Yeah, in the verb, and what we have here is we get a property of subjects, namely that the height of the subject, the height of the subject is in this set here, so lambda d. So the height of Martin is bigger than d. And of course, if you take here the height of that subject here, you can again lambda it into the second position, and you get here as a meaning for the entire phrase, the lambda x. So the set of the x to the height of Martin, it's taller, than it's bigger than the height of x. And now we can apply, when we have calculated this here, we have the right type, we can quantify in the subject. You see, up to that point, that was the second step here, and here every girl we can of course now apply simply to that property here without doing anything. And the meaning of every girl, it's what it always was, and if every girl is applied to that what we have here, we get at the end for every girl, we have it that the height of Martin is taller than every girl. Let's look. I mean, it's really a bit tricky, the entire thing. So what's the systematics? Again, the systematics is somehow you raise the adjective, and that trick here, I mean, it's this trick here has always the effect, you can prove it. If you have a quantifier in the then clause, it will automatically have wide scope with respect to the comparative. It's always, that's the outcome. Do the calculation a bit for yourself. And so that's a prediction. That's basically exactly the theory of Wilkinson and Schwarzschild, or Schwarzschild and Wilkinson. And let's have a look again, because maybe it, I mean, it's a bit difficult to follow. Again, how this is done here, so you see, get a feeling for the derivation. So you see, we have raised the adjective, and the adjective has not a degree variable. It's not a degree argument, but it takes as an argument a set of degrees. It's an object, so to speak. That's the important thing. And you see, then what we have here, you see, at this particular, we have, as we had before, Martin is more than what every girl is tall. That's the usual syntax. But you see, again, I mean, here at this whole thing here must be of the degree type. And of course, what we do here in the first step, we QR it the entire more than what every girl is tall. We QR that, leave a lambda d exactly of the set type, leave it at that place. You see, this is right. This is right. And then we still have inside of the entire thing here, then what every girl is tall, we have still a type clash here, namely that the comparative morpheme, has a very simple meaning, simply a relation between degrees. So we have, and here we have a quantifier, a quantifier of degrees, and so we have to QR that, leave a variable of the lower type, so lambda d, that's written here, it's lambda 2, and you see it's a d type, it's written here. We outscope it, we outscope it, then we have the usual meanings, and we outscope it, get this here, and then every girl is d tall, And then perhaps, yeah, that's it. I mean, every girl we don't have to scope, yeah, because it's every girl, it's in the subject position, yeah, in the subject position, and it takes something of the type ET, yeah, and it's clear that when you have an adjective, even its higher order, and at the first type, at the first argument takes a set, the result is something of the type ET, so it's not necessary, yeah, to move the every girl. If you calculate that, I always do it myself, then you find out, you can do it yourself, it's all on the handout, completely mechanical. It really has the effect, and the general effect is the quantifier and the then clause always get wide scope with respect to the matrix. Yeah? That's the effect. Yeah? That's an observation from an old paper of old paper by what did I say, Larsen, yeah? And he didn't do it that systematically, so that's basically Schwarzschild and Wilson theory. So now you see an evaluation of this approach here, and this cannot be correct for NPIs for two reasons. Yeah? So if you have Martin is taller than any girl, yeah, and if any, as usually people assume means the same as some girl, yeah, then we have the prediction that this means Martin is taller than some girl. Yeah. The second thing is, if you calculate, and if you calculate, if you look a bit more carefully, you see that the spot, yeah, the context created by the then clause is not a downward entailing environment. Yeah, you can prove that. I don't want to do it. Yeah, so NPIs in the first place are not licensed at all. Yeah, and this theory, that cannot be okay. And then the other thing, another drawback, is that negative quantifiers are predicted to be okay, and they're also predicted to give the wrong meaning. So, for instance, you see Martin is taller than no girl. Yeah, since the quantifiers in the then clause always have wide scope with respect to the Martin, with respect to the comparative. It means there is no girl such that Martin is taller than her. Yeah, and the sentence certainly doesn't have that meaning. The sentence means rubbish. Yeah, right? And then the other thing is, it also predicts that modals, you can calculate that, and that they are predicted always to have wide scope with respect to the matrix. So, for instance, that's fine with it's warmer today than it might be tomorrow, and John is more polite than his secretary must be, but it can't account for the narrow scope modals, and he was more cautious than he needed to be. He charged more than he was allowed to, and so on. And this is the normal case, yeah, for the modals. The same for the adverbs of quantifications, yeah. So it's clear, yeah, because this a unified treatment. It's always the moral, yeah, you can take, yeah, from this thing. There's a unified treatment, yeah, for all of these things, yeah. And that can't be right, yeah? And somehow you must make a distinction because these things behave differently. You want to say something? Yeah, no. Yeah. Okay.
Can we interpret the integer? Can we interpret the integer in the then clause and the free choice and?
As what?
Free choice and. So it's not.
Yeah, I mean that's correct. I mean, and so it's a bit. It's a bit difficult, yeah. It's a bit difficult to argue with any, yeah, because you could say it's a free choice, yeah, and then so one shouldn't base too strong arguments on any. I think, yeah, that any and has two meaning. It has a free choice meaning, and it has a negative polarity and NPI meaning. Yeah, but so any perhaps if you say then of course you would have you should have a theory for free choice, yeah, and look whether it comes out correctly. So the free choice basically should behave as those quantifiers that automatically somehow take wide scope, yeah, and then it might come out correctly if it were a free choice, yeah, in that context. So, for instance, we should say, so every any is a free choice, yeah, but that's presumably not correct, because if I say I haven't maybe, yeah, if I haven't spent any money or whatever, or I haven't any money, usually people say there's not a free choice, but perhaps, yeah, if you have a unified theory of with free choice and NPIs, yeah, that unifies them, you could say that. Then we still have the problem with other NPIs like ever, etc. Yeah, so with ever you see, so they are more unproblematic items, yeah, and they are also predicted to have wide scope, yeah, and this is not correct, yeah, because that would give you, for instance, I'm stronger than ever, and would give you the meaning, yeah, as I'm stronger than I was at one time at the past. Yeah? So there's one time in the past, and I'm stronger than I was at that time. That would be the prediction. This is not correct, because it should be so for every time in the past, yeah, I'm stronger now than at that time. So that's a prediction, yeah. Okay, but you are right, yeah. You shouldn't base too much on these things, yeah. And okay, yeah. Right, yeah. So so if you don't like here, so like anybody else, to have it as an NPI, so think of one of these adverbs, yeah. Right, and well, so there's some really deep flaws in this theory. Also with negation, comes out totally wrong. Yeah, it's clear. And Schwarzer, and they can't do anything against that. Yeah? Now, Heim in recent papers, a couple of years started already, was with a short hint in 2001, I think, my Festschrift. She invented a P operator, and this actually now, I don't know how she calls it, to look it up. It's on the paper here in the thing, but Schwarzschild has called it then a P operator. It means point to interval, yeah. I tell you what it is, yeah. The idea is, yeah, I first introduce it and then I try, yeah, to explain it carefully, yeah. And the idea is, yeah, that you actually start, yeah, and you start with the old adjective. We have the time, not Schwarzschild, yeah. And you actually start with the old meaning of the adjective, namely tall. It's this interval meanings, yeah, and it tells you, well, it relates an x, a subject x, which all the degrees, yeah, that are smaller or equal to the height of x, yeah, so that interval. So that's the old meaning we had already, yeah. And now, what the P operator does, yeah, the P operator, it's a quantifier, yeah, it's a quantifier, it's a bit more complicated thing, and the P operator raises that thing to Schwarzschild meaning. We had it before, yeah, and the P operator, it's a sort of combinator if you want, and you can scope now. You can scope now quantifiers either under the P or over the P. That will come out. And if you scope them over the P, and if you calculate the things, these quantifiers will have wide scope with respect to the matrix. And if you scope them under the P, yeah, they will have narrow scope with respect to the matrix. That will come out in the theory. Yeah, and then you have to, by a bit of stipulation, yeah, try to get the distribution right. You will see that this can't work. Yeah, for negation, it comes out that it comes out in the wrong way as well, and that's almost where we will go, because we won't solve that. Yeah, I will maybe then briefly hint what Sigrid Beck has done in the most recent paper. It's wrong. Yeah. So I convinced myself it doesn't work, but I give you. I won't have the time to explain that here, but I tell you what I think it's wrong. And well, let's have a look. Yeah, what the P is. Yeah. The first P, the first argument of the P is a degree variable, or simply a set of degrees. Yeah, it's a set of degrees. And the second thing, it's also a set of degrees, and it tells you that the maximal degree is in that D. And see, the maximal degree is point. Yeah, it gives you one particular degree, a maximal degree of an interval, and that's in the degree, and that's why the meaning P, point to interval. Yeah, you see, if it's in a way, so the first thing is a point. Yeah, it's a point you get, and the second thing it's an interval. Interval, it's a funny word. People always use it. As I told you, this isn't an interval. Yeah, it's simply a set. Yeah, it's simply a set. So call it an interval. It's not okay, but people do it. Yeah, and let me now look how it looks. It's even more tricky, but we still have a bit of time, yeah, and we'll go through that. Yeah. So we have the simplest comparative meanings, namely, comparative morpheme still relates to degrees and says that the second one is bigger than the first. Yeah. So then clear. Yeah. And I'll give you now the main structure and how this is done. Yeah. You see. What we have here, when we do the generation, so Martin is taller than Anna. Yeah? Basically, what we have, yeah, we combine as before. Yeah? It's very similar to what we had before. We have something, yeah, like Martin is more tall than, yeah, and we have here, this is a degree phrase. Yeah, this is a degree phrase. And this degree phrase is, the degree phrase is modified by, it's P, that's the same P as above. I couldn't write it in capitals because of my tree writing program. So it's the same here. Yeah? And this is a P. And you see the RD as before is a set. It's a set of degrees because the R is a simple meaning. If we apply it, yeah, to a D, we get a set of degrees, yeah, and the P operator converts this set into a general quantifier and says that the maximal degree, yeah, of Martin's tallness, so that's basically Martin's tallness, is in that set of the things that are taller than D. Yeah? That will be more or less the meaning. Yeah? That will be more or less the meaning. And the then clause, is more or less also as before, is the raised thing we have to extract, yeah, for type reasons. Yeah? It basically comes out, yeah, it's from the complement position of that ER. And again, yeah, since it is a generalized quantifier over degrees, but it's generated by the P operator, yeah, and that's it. So that's the structure. So structure is basically like before, but so to speak, the raising is not put into the adjective meaning, yeah, but the raising is done by the P, and the P itself, yeah, has a variable that can be bound from outside. So it's a bit tricky, but look a bit how we generate it. Yeah, we have here let's look at the generation of the then clause. John is taller than Mary. Yeah, so what we have here, we start here with Mary is P, then P WH tall. Now this is at WH takes at the object position set. And this is the WH is always a totally empty thing. Yeah? It's totally empty. It's a WH operator, so we have to move it for type reasons, leaving a variable of the type D, of the set thing. So we move that out and get that position here. Right. Yeah? that looks good. And what we have here, well, in the first step already, I have a bit, you see this entire DEG phrase has already been moved outside of the adjective. This is also a movement, so that's the first step. Yeah, you move the DEG phrase out of the object position of the adjective. Yeah, then you move in a further step the WH from the object position of the P operator, and then you get this thing here. So lambda D. Yeah, lambda D. That's the sets. Yeah, and you say, well, intuitively, the maximal degree, this is intuitively then the maximum degree in that interval of set of degrees that goes up to Anaheiß. This is Anaheiß, is in that D. So the meaning is really you get exactly what we had before, and you see that that's the meaning of the P operator. The P operator at PD is the set of properties of this type here, PD. So the maximal degree in that property is in that D here. Yeah? Well, and if you look that as before, we have here, of course, here the set lambda D Anaheiß D tall. That's the usual stuff. Yeah, and if we apply the P operator to the set here and to the set, we get if we calculate that, exactly what we had before, namely that the height of Anna is inside the D. Yeah? But you see, that's what we had before. There's nothing new. Yeah? But if you look at the syntax, we have here a nominal. Yeah? We have here a nominal, and if we have a quantifier in the then clause, it can take scope under or above the P. That's the idea. Yeah? That's the structure. Well, and now we look the generation of the main clause. It's the same, but it's of course it's exactly the same. We have here, you see, Martin is well. We have the DEG phrase is we have a P, and that's the subject of the ER. Then we have the then clause, and then we have tall, and we have this, so to speak, the complex degree phrase. We have the tall thing, and now we have to QR the then clause. We have to QR the then clause, and we get where's the then clause? Somehow, somehow it has disappeared. So it disappeared here in that calculation, but think of it, it's there. It's simply, if we QR the then clause, it certainly leaves here a lambda D, and this is inside of the P, and the then clause is outside, in front, forgot it, and now we QR the entire P phrase, because it's still, you see, here we still have a type clash. Recall that the we need something of type D here. We are in that other still that other framework, and we get this here. So we are still inside. So the lambda D is outside, and we scope it out of the adjective phrase, and we get that here lambda D and this structure here, and well, and if you look at the calculation, the calculation of the main clause basically means, if you look at that, this is a maximum operator, so we get the set of degrees, so the height of the subject is taller than that degree. You see, this here, this here is really the set of the things that are taller than T, that are taller than T, and if Martin's height is in that set, it means that the height of Martin is taller than that particular degree. So this is what you get. This is what we had before, and this is exactly the result. And if if we apply the then clause to the main clause, yeah, and we get this here. That's the calculation. You can do it for yourself. That the height is Anna. The height of Anna is the height of Anna. Here is something wrong. So so this here you better skip. So this D, it's still a copy error. It's in the set of the lambda D, and height of Martin is bigger than D. So it's an error here. And then we get the height of Martin is exceed the height of Anna. Yeah? This exactly as we had before. Yeah? But yeah? As I told you, we can now, we have a thing here that has scope, yeah? And so the every boy, yeah, can have narrow scope or wide scope with respect to the P phrase. Yeah? You saw it in English class. Is it P or pi? Pi, perhaps. Pi? Huh? It's really German here, so it's pi. So the pi phrase. Yeah, okay. And okay, but you understood me because you. Now, you see, we have two. If we take, let's for a moment, yeah, give every boy wide scope to respect to the P. Yeah, so every boy from the adjective. So you see, we lambda it at the subject position. We scope it over the P phrase. Yeah, and if we calculate it, yeah, we get this here. So it's lambda D. So and this is a higher order thing. So these are degree sets. So for every f, it's x is a boy. Then the height of the boy is in D. If you look already at that, you can see it. Yeah, that eventually when we scope when we scope in the main clause, yeah, that every boy gets wide scope, yeah, and to respect to the main clause. You see it already from this structure here, because this is, so to speak, the place here for the main clause. Yeah, there it is. And if we have narrow scope, yeah, if we have narrow scope, you see here the every boy has narrow scope with respect to the P operator. Yeah, then we get this here. Yeah, so so again, what we had before in the old theory. So the maximal degree, such that every boy, yeah, such that for every boy we have it, the height of that boy is bigger or equal of that degree. This is actually, if it is the maximum, that's for everyone. Yeah, it's taller than that, so we must go into the intersection and look at the smallest one they all have. Yeah, and this is, of course, it's the height of the shortest boy. Yeah, must be in D. Yeah, that's the point. Yeah, it's always with the universal quantifier. So here we can scope, and here we have, well. If we have matrix scope, it's clear. If we have matrix scope, I don't want to do too much in the calculation. It's all in the handout. Yeah, you scope it out. I mean, let's look. I mean, if we have matrix scope, every boy must have wide scope with respect to the P operator. Yeah, and I mean, here I've done a bit of the calculation, and eventually you finish at that that LF here. So you see, this is then clause, yeah, and you see then what every boy, yeah, is told that every boy has wide scope with respect to the P phrase, yeah, and here the main phrase we don't scope anything in the mean phrase, and if you calculate it, that's done here, yeah, on the handout, and you get precisely, yeah, that what we want to have, namely, for every boy, yeah, we have it that the height of that boy, that the height of the subject, Martin, is taller than that boy, yeah. So that's fine, and that you can simply calculate it, and it really comes out. It's all mechanical. It's a bit tricky, and it takes some time. And if we have narrow scope, that's also a calculation here. You see it. I mean, that's the essential thing to remember, and the essential thing to remember, so that every boy would have scope under P, and then you calculate it out of this formula stuff. It's all included in a handout, and you get that the height of Martin is taller than the height of the shortest boy. Now, since what's the outcome? We still overgenerate. It's clear, yeah, and we still overgenerate, and so because we only want to have so Martin is taller than every boy, that Martin is taller than the tallest of the boys. That's clear. That's what it means. Not as short as. I mean, and therefore, somehow we have to block the reading where every boy has narrow scope with respect to the pi operator, right? We have to block it. I mean, that's what all these things you see. Before we don't, the difference is, we don't have to move out now to get the correct movement. It's not necessary that the quantifier every boy leaves the then clause, so the respect clause boundedness, but still there is a sort of thing he has to jump over, namely that the P operator. Does it jump over it? You see it perhaps not, Perhaps we could say, you see, if we generate the entire thing and we start from the deep structure, the order is this. First we have the subject, every boy, then comes, of course, at the P phrase, the pi phrase, PR then, no, that's the then clause, PD, and this stays in the at the object place, and perhaps it is that way. If we scope the pi operator, it should scope over a quantifier. So, and that's in fact what Heim stipulates, and she says that the pi phrase doesn't move over a dp quantifier. So that's it. Fine. Now you see with modals, obviously that doesn't hold, because you see the modal is like need, Need is a universal quantifier over words, so it means that in every word that fulfill our needs, blah blah blah, but this is a verbal quantifier, and it seems to be the case in the P phrase. It's an argument in a way. It's generated at the argument position, an argument of at the deep position, and this can move over this modal here. This can move over that modal, and then the need has narrow scope with respect to the P operator, and if we calculate it, we get the correct meaning that's said here, namely, we take the smallest, we come out to the smallest degree, and we get a minimal reading. So a minimal reading, so narrow scope with respect to the P operator. So for instance, you see it here, we get the set of degrees such that the maximal degrees, the maximal height that Martin has in every in every accessible word, it's taller than D. The maximal height is in that D, and this is a minimum reading. This is a minimum reading. Okay, and this we can evaluate as before. Now, again, we have to stipulate something. Namely, you see. Epistemic modals, like might, and certain must, ought, and so on. There are we have to stipulate. Well, it's in effect an observation that these modals always take wide scope. So in a way, we stipulate that the pi phrase doesn't move over these modals, right? Okay. that we have to live with that stipulation, and then we can calculate as we have done before. So it's warmer today than it might be tomorrow. Yeah. So we get since the LF has this configuration, you see, first we have the might, then we have the pi phrase, and then we have the lambda d. It's warm today tomorrow, yeah? And if we calculate that, we get a maximum reading because, as I told you, yeah, the might has wide scope, so the reading is might is an existential quantifier, and we get a minimum reading, yeah, because we have an existential quantifier. So we have one accessible world, yeah, where the maximal degree, the maximal degree in such that is warm, that can be reached tomorrow, is in that set. I mean, there are many accessible worlds, so we can take one with the minimal temperature. Yeah. So this maximal operator doesn't count, as I told you. If we have an existential quantifier that has a wide scope with one of my friends, etc., would be another case. With respect to the pi operator, then we get that minimum reading. Here I have it calculated for you. If you go through all that stuff, you see it comes out correctly. Yeah? I mean, that's the systematic you bear. So basically, remember, yeah, wide scope with respect to the pi operator, matrix scope, yeah, narrow scope with respect to the pi operator, and scope in the then clause. That's in the theory. That's the outcome, yeah, of this theory here. And you say to NPIs, we have to. That's tricky. Yeah, you have to look a bit in Heim's paper, but also there it is. 2006, it said in more details. The pi phrases, yeah, are not creating themselves, yeah, a downward entailing spot. So, for instance, if we have here this configuration here, so we have a downward entailing, we have a Q, yeah. So the pi first takes always this variable. It's the first argument, and then it's the proper scope. Yeah, it's Q. Yeah, and it would downward entailing. If for any subset of these, yeah, then it should also be true of that. But this is, of course, not the case. I mean, I give a counterexample. It's a very trivial counterexample. So, for instance, we can here the lambda d, yeah, the height of Martin is bigger or equal to d with a maximum, and the maximum of Q would be 2 meters. It's exactly his height, yeah, and then we have a subset here, for instance, the degree that go up to Sveta's height, yeah. So, and it's of course clear that for this subset, yeah, we don't have it. That it's also true, yeah, of that the formula is true of that. It's obviously not so. Yeah. So it's very easy to show that this is not downward entailing. But if we have a certain syntactic configuration, that's a quote here from Heim, and you look at this. You look at the then clause. Yeah, you look at the then clause and its Heim notation. Here we have the pi operator, and it's at the beginning of the then clause. Then comes the phi, yeah, and then comes here comes the rest. This here, in this particular syntactic configuration, yeah, we can show it, and that's the only one we are interested in. It creates a downward entailing context. That one has to show. It's not too difficult. It's also in Heim's paper. And that means that's precisely what we have. Yeah? If we have an NPI under the pi operator that occupies the pi operator stands in an initial position of the then clause. Yeah? And if the NPI stands directly after that pi operator and the scope of that, if it's there, then it is a downward entailing. It's a downward entailing context. You can show that. So NPIs would be licensed. Would be licensed if they directly occur in the scope of the pi. Well, this is also very odd. Yeah, it's very odd. You see, the point is, if we consider, I mean, you can make that the same point here with adverbs, of course, too. If we consider a thing like Martin is taller than any girl, then if we start the generation, as you see, the pi phrase is first generated under any girl, but we have to ensure that any girl is in the theory, is in the scope of the pi operator. So here we have to enforce movement. Here we have to enforce movement of the pi operator over any girl. Otherwise, it simply doesn't come out correctly. It doesn't come out. It doesn't come out correctly. And this is a funny thing, and Heim speculates, well, I mean, why should, I mean, there's also Kennedy's constraint. It says that, no, it's not relevant here, sure, take it, so deck phrase never moves over a quantifier, but here it has to move, and a degree phrase, and what can that be? And Heim says, well, perhaps it's so that NPI has to be licensed, has to be licensed in a configuration, say at least at LF, and if the pi operator is under the pi phrase, it's under the NPI, then the NPI, it's an upward entailing context, it wouldn't be licensed, since it has to be licensed by a scope-bearing element, and if we can license it by moving it, so we move, and we license it. So maybe not a very good theory, but that's what we have to say. So NPIs are seem to be there's at least to account for NPIs. So the idea is NPIs enforce movement, directly above the scope of the pi phrase. So, and here she gives Heim in that paper that's quoted in the handout gives some very interesting examples. And for instance, it's sometimes possible that even a thing that takes positives, that a positive operator that has usually matrix scope might be, so to speak, trapped by an NPI if the NPI is above it. For instance, if you say something in German, er ist höher gestiegen, als gestern ein Amerikaner gestiegen ist. So this might have, you see here is, or one of my friends, doesn't matter. So he climbed higher than yesterday, and then one of my friends climbed yesterday, als höher gestiegen, als ein Amerikaner gestiegen ist. You see, it means here there's an American, and he climbed higher than. That might be any American, and it could be. It's not necessary that the one that climbed highest, but anyone. And now it could be. If you have read Mark Twain. So that man didn't climb very high. If you have read the climb of the Rigi, took them 2 days. And so is. But if you have an NPI in German, er ist höher gestiegen, als jemals ein Amerikaner gestiegen ist, then you suddenly it's clear that this, an American, yeah, he climbed higher than any American ever did. Yeah, it suddenly, he has climbed higher than, the highest American climber. Yeah? And the point is, yeah, you see, this jemals, yeah, it's the only good NPI we have in German, we're scarce in our language. It's, this has to be licensed, so we move the pipe phrase, yeah, in top of the jemals, yeah, and that automatically gives thou, yeah, alone, yeah, an American is not licensed in these contexts here, but here is his license. It's trapped, so to speak. Yeah, so that's a good. And for other more subtle data, look at Irene Heim's papers now. Yeah. There's a serious theory. When I prepared that course, I discovered it myself. I thought it's not discussed in Irene Heim's paper, because I thought it was more or less quite a good solution. Namely, this has been noted, but in back papers, I quoted here, I didn't give the handout, yeah? And you see, the theory as it stands, yeah, automatically tells you that negation has wide scope with respect to the matrix, and for instance, Martin is taller than Anna isn't, yeah? Predicted by this theory is Martin isn't taller than Anna, yeah? And this, of course, not what it means, yeah? And well, here I've done a bit of calculation, yeah? So you see, then Anna isn't as this reason here. You have the lambda d, the not, and you have the PD. Anna is tall, and this means it's lambda d. It's not the case that the height of Anna is in d, yeah? And Martin is taller. Martin is taller than means so lambda d, and the height of Martin is bigger than d. And if you apply here the then clause to the main clause, you get precisely what I said. It's a very easy calculation. You see it. I mean, once you get used to it. And similarly, is Martin is taller than no girl, means there's no girl such that Martin is taller than her. Yeah? Thus, it's everything is fine here, but it's the most serious objection. I have not the slightest idea how this could be fixed. Yeah. Okay. Now, this is as far as I wanted to go, but I tell you, you have now found. Let me repeat. Yeah, what we have. Yeah, what we have Heim's theory with the pi phrase. We have a scope-bearing element. The pi phrase does the lifting. Yeah, to the adjective to the generalized quantifier level, and then the quantifiers or adverbs can have scope with respect to the pi phrase. Yeah? And if we scope can be generated in two different ways. Yeah, basically by moving the pi operator. Yeah? We have to say that if things that obligatorily take matrix scope, like everyone, etc. So every, etc. And also certain things. There it is. So it's a sort of Kennedy's constraint. We are not allowed to move the pi phrase over them. Yeah, that's not allowed. But for other things, for NPIs, for NPIs, we have to move them. We have to move the pi phrase over them. For most of the adverbs, it's also stipulated that we have to move and modals, that we have the pi phrase above these modals. But for some, the epistemic, it's not allowed. And everything fine. Well, a lot of stipulations, of course, but everything fine. But we have a problem with negations. Yeah, the problem is you could, perhaps stipulate that you have to move a pi operator across negation, across negation above it. You could stipulate that, That would make all these sentences nonsensical, As before, we would have intervals that are not defined, etc. So that would carry over, but that would be a very odd stipulation, because I mean, we know if something is a barrier for LF movement, then it is negation, I mean, if we stipulate that the pi operator always has to take wide scope about negative things, negation, then all the sentences are ruled out again because we can't interpret it. So it's an odd stipulation. We have to stipulate and we move something in order to produce something that we cannot interpret. Yes, it's really odd. So that's the outcome of that theory. I have here, it's on the home page. Only want to mention that there is another approach of Sigrid Beck here that I wanted. I didn't have. If I had a bit more of time, I would have discussed here. It's an approach of doing basically the same as Schwarzschild with some pragmatic operations, and this doesn't work at all. I mean, it doesn't work well. It doesn't work well for most, as I had convinced myself. For non-standard quantifier, it makes totally wrong prediction, and it doesn't work for it doesn't work for things like existential quantifiers that take matrix code. It doesn't work at all. So I thought first it was a good approach. That's why I thought it. But for two things, it's irreparable. So maybe. The idea is, I don't have the time here because it's now 17 to go into Beck's theory. Basically what she does is she has the old Schwarzschild semantics, and then she has a strategy. She produces among sets of intervals, she takes one of a minimal length of a set of intervals and consider those that's extended most toward it extends most toward the bigger part of the scale, and among these intervals she takes then the highest degree, and for certain cases it works. It's a pragmatic strategy, like for every boy. For other cases, very simple cases, it's a totally wrong prediction. So she hasn't calculated that, but I don't have the time. But time is over, so maybe you still have some question. In any case, then I thank you very much for coming and for listening. So I hope you have learned one thing or the other, and learned also some methods. That's it. Okay.